waning gibbous moon will interfere, reducing the number of visible meteors. Now for the good news. That same moon is heading toward the sun, narrowing as it goes until the thinning crescent disappears into a black disk that will perfectly cover the sun on August 21st. A meteor shower followed by a total solar eclipse. August doesn't get much better than that. For more news about backyard astronomy, stay tuned to science.nasa.gov.
Watch NASA Television's pre-show coverage at 12 p.m. and the entire total solar eclipse coverage through the eyes of NASA at 1 p.m. Eastern, only on NASA Television.
Hi, I'm Noah Petro from NASA's Goddard Space Flight Center. The eclipse has just passed over us here at Volcano Stadium. You all in Charleston have a great show coming your way. Now, because we've got NASA at both stadiums today, we wanted to connect the two events, creating a Transcontinental Eclipse doubleheader. Now, I know Paul Hertz is there today. Paul's the Division Director of Astrophysics at NASA headquarters. Now, Paul, we've got a ball here to send your way. Now, Paul, I'm going to throw it as hard as I can. I hope you can catch it.
Great throw, Noah, but I don't think either one of us is ready for the major. I'm here at Charleston River Dog Stadium, and we're looking forward to a beautiful eclipse and an exciting ball game. And I hope everyone at Volcano Stadium enjoyed the eclipse and enjoys the rest of your ball game. Today is a great day for America, for baseball, for NASA, and for anyone who enjoyed the great American eclipse. Thank you.
A solar eclipse occurs when the moon moves between the Earth and the sun, blocks the sun's light, and casts a shadow on the Earth. When the moon completely covers the bright disk of the sun, that's a total solar eclipse, and it happens roughly every year and a half somewhere on Earth. A partial solar eclipse is more common, happening at least twice a year. A lunar eclipse, on the other hand, is where the moon moves behind the Earth, so it's now the Earth blocking the sun's light on the moon, creating a shadow on it with a red tint. The easy way to remember the difference is to remember what gets darker. With the solar eclipse, the sun gets darker, and during a lunar eclipse, the moon does. A solar eclipse is a rare event that not many get to see, because the moon's shadow is relatively small. This limits the locations on Earth that get to see it. You have to be on the sunny side of the planet, and you have to be in the path of the moon's shadow. So, if you find your area in the path of totality one year, you've hit the jackpot, because on average, that same spot on Earth will only get to see a solar eclipse every 375 years. During a solar eclipse, the moon casts a shadow with two parts, the umbra and penumbra. The moon's umbra is part of the moon's shadow where the entire sun is blocked by the moon. In space, it's a cone extending some 400,000 kilometers behind the moon. It's when the small end of this cone hits the Earth that we experience a total solar eclipse. Most eclipse maps depicting the path will show you a circle representing the shadow of the moon, but in actuality, the true shape of the umbra is more like an irregular polygon with slightly curved edges. This is because the moon isn't a perfect circle. It has mountains and valleys on its surface, which all affect the passing sunlight and subsequent shape of its shadow. And scientists now have a greater understanding of the shape of the moon's surface, thanks to NASA's Lunar Reconnaissance Orbiter. The unprecedented level of detail from the topographic maps, photos, and other datasets has allowed us to more precisely pinpoint the regions on Earth falling within the path of totality of a solar eclipse. So, if you get the chance to witness a solar eclipse, always remember that our little moon plays a role that's quite large.
What's up for August? August 21st's total solar eclipse traces a narrow path across the nation, though most of the U.S. will see a partial eclipse. Hello and welcome. I'm Jane Houston Jones from NASA's Jet Propulsion Laboratory in Pasadena, California. Not everyone can travel to the narrow path of totality, so here are some things to look for no matter whether you see totality or a partial eclipse. Before Eclipse Day, pack your Eclipse toolkit with a notebook, pen or pencil, a clock, a stopwatch, the front page of a newspaper, a thermometer, and a stick with a piece of crepe paper tied to it. And bring an assistant to help conduct some science observations. Practice using a citizen science phone app to help you study clouds, air, and surface temperatures during the eclipse. A good one is the Globe app. Go to the location where you'll view the eclipse and check for trees and buildings that may obstruct your view. Totality lasts less than 3 minutes, so you may want to focus on doing only one science observation, or just really experience the eclipse. Don't waste this once-in-a-lifetime opportunity by watching it on your phone screen. Plan to have your safe solar viewing glasses within immediate reach, in your pocket or around your neck for quick eye protection before and after totality. Just before totality, if you have a good view of the horizon, look west for the approaching shadow. After totality, look east low on the horizon for the departing shadow. If it's cloudy, try to see the shadow by looking up at the bottoms of the clouds. During totality, look for stars. Can you see Regulus in the solar corona? The stars of Orion? How early and how late is Venus visible? Can you see any other planets? Before and after totality, you may see moving waves of light and shadow, like the patterns you see on the bottom of a swimming pool. How dark does it get at totality? As it gets darker, look at the newspaper you brought and see what's the smallest print you can read. How much does the temperature drop during totality? Does the wind start, stop, or change direction? Watch and listen for changes in animal and bird behavior. During the partial phases, use your hands as a pinhole projector. You'll be able to see the crescent shape of the sun projected through the spaces created by your fingers. You can also make a paper pinhole projector. In fact, any item with one or more holes in it, like a kitchen colander, a loosely woven straw hat, even leaves on trees, will project the crescent shapes. You can find out about all of NASA's missions at www.nasa.gov, and you can find out more about the eclipse, including eclipse safety, at eclipse2017.nasa.gov. That's all for this month. I'm Jane Houston Jones.
There are two important things to remember about watching a solar eclipse. The first one is never look at the partial eclipse that comes before and follows after a total solar eclipse. Even if 1% of the sun is showing around the edge of the moon, that's too bright for your eye to handle. It will damage your vision. The second thing, however, is do look at the total solar eclipse with your naked eye. Your eye is an amazing device and will show you lots of detail during totality. Today, I'm going to show you several techniques for viewing a partial solar eclipse. The first one is to go online and to buy a pair of solar viewing glasses. These have been designed to block the sunlight during a partial eclipse or even the full sun so that you can look at the sun with your naked eye. The second is to go to a welding shop and get a number 14 welder's glass. This blocks enough of the sunlight that you can look at it safely with your eye. A third technique will be to make a pinhole in a piece of cardboard and then make a pinhole image of the sun. And the fourth technique, which we'll take you through today, is to use a small telescope, a spotting scope, or a binoculars to make an image of the sun projected onto a white piece of cardboard. This was the technique used by Galileo himself. All of these will allow you to watch the partial solar eclipse and save your eyes.
Watch NASA Television's pre-show coverage at 12 p.m. and the entire total solar eclipse coverage through the eyes of NASA at 1 p.m. Eastern, only on NASA Television.
The most amazing thing was when I was in Turkey in 2006 and I saw a total solar eclipse live and in person.
I am just getting chills, literally and figuratively, about the excitement of this amazing spectacle.
As an astronomer, I felt lucky enough to be witnessing the fact that we are part of a moving solar system in which you have the Earth, Sun, and Moon interacting together. As a person, I felt very moved when I saw totality in the middle of the day. Totality is when the moon covers completely the sun, and so all the light that we normally see during the day from the photosphere of the sun completely disappears, and the only thing that you are left seeing is a dark sun, completely blackened, and then on the outside of the sun, the corona is visible. So we're going to show you what happens to create totality, to create this darkness in the middle of the day on the Earth's surface as a result of a total solar eclipse. So basically I have a fictitious sun behind me, which is a light source, pretending that it's the sun, and we have the Earth and we have the moon. So the moon actually travels in front of the Earth, covering the sun, and that's what causes the total solar eclipse. Did you see that shadow, Lily?
I did.
There it is. So basically that shadow creates what is called a path of totality, which will be a strip of darkness. This is not exactly to scale, but it is helpful to see. It's very simple. The shadow of the moon is cast upon the surface of the Earth. The moon is indeed much smaller than the sun. 400 of these little moons will actually cover the diameter of the sun. But the moon is also 400 times closer to us, and that is what creates the total solar eclipse, which is an amazing cosmic coincidence. So to illustrate what I'm talking about, I'm going to use my thumb, which is much smaller than your head, to try and cover it. So if I try to cover it here, I close one eye, you're still very visible. But if I bring my thumb very close to my eye, eventually your entire face is actually covered. And that is what's happening. And you can try this at home. Do that with different objects and different distances using your thumb and closing one eye, and you'll be able to understand why the moon, which is 400 times smaller than the sun, but is 400 times closer to us, can actually cause the sun to be completely obscured in a total solar eclipse.
If the moon goes around the Earth once a month, how come we don't have an eclipse every month?
The orbit of the moon around the Earth is actually slanted, so most of the time the moon will actually travel above the plane of the Earth and the Sun line or below the plane of the Earth-Sun line and not cause an eclipse. We are not going to have a total solar eclipse forever. And that is because the moon is actually receding from the Earth. The distance is actually increasing due to tidal forces. And so, of course, as the moon recedes from the Earth, it covers a little bit less and less of the solar disk during an eclipse. But this will happen in 500 million years. So we still have time to go out there and catch a beautiful total solar eclipse.
As the darkness slowly encroaches, do not fear. The sun will shine again. On August 21st, a total solar eclipse will cross the United States from Oregon to South Carolina. And for a couple of minutes, day will turn into night. Enjoy the show, but don't look at the sun. The only safe time to view an eclipse is if you're in the path of totality and during the minutes of totality. Otherwise, you'll need certified eclipse glasses. To learn more, go to eclipse2017.nasa.gov and NASA TV.
Watch NASA Television's pre-show coverage at 12 p.m. and the entire total solar eclipse coverage through the eyes of NASA at 1 p.m. Eastern, only on NASA Television.
On August 21st, 2017, a solar eclipse will pass over all 50 United States. This will afford most of the country a glimpse of what it is like to have the moon slide between the sun and the earth, casting a shadow on us down below. The experience will look different depending on where you are located. If you are along the path of totality, you see the moon fully block the sun. If you are outside of the path, you will see the moon go by, but the sun will never be fully covered. Wherever you are, you never want to look directly at the sun without protection. Like eclipse glasses, not sunglasses. The one exception is if you are able to see totality. Only when the moon has fully blocked the sun, you are safe to look at the eclipse directly. Before and after that moment, keep your eyes protected. Events like this are rare. The last total solar eclipse to cross the U.S. coast to coast was in 1918. And the next total solar eclipse in the continental U.S. isn't until 2024. Don't miss this opportunity to experience a solar eclipse.
Space Place. In a snap. Whoa! It's the middle of the day. So why is the sky getting dark? It's a solar eclipse. A solar eclipse happens when, at just the right moment, the moon passes between the sun and Earth. Sometimes the moon only blocks part of the sun's light. This is called a partial solar eclipse. Other times, the moon blocks all of the sun's light. This is called a total solar eclipse. As the moon blocks the sun's light, it casts a shadow on part of the Earth. The moon's shadow creates a trail as the Earth rotates. This trail is called the path of totality. If you want to experience total darkness during an eclipse, you have to be in the path of totality. In that path, the moon completely blocks the sun's light for a few minutes. It gets so dark that it looks like nighttime during a full moon. If you don't know what's happening, it can be confusing. Animals can get confused too. But this total darkness can also be kind of cool for scientists who study the sun's atmosphere, called the corona. The corona is very dim. It's usually hard to see because the sun is so much brighter. But when the moon blocks the sun's light during an eclipse, all you can see is the light from the corona. Total solar eclipses over the land, where people can see them, don't happen very often. But when they do happen, the moon gives scientists, and the rest of us, a glimpse at the corona's beautiful streams and ribbons. Thanks, Moon. Find out more about the sun at NASA Space Place.
Watch NASA Television's pre-show coverage at 12 p.m. and the entire total solar eclipse coverage through the eyes of NASA at 1 p.m. Eastern, only on NASA Television. Watch NASA Television's pre-show coverage at 12 p.m. and the entire total solar eclipse coverage through the eyes of NASA at 1 p.m. Eastern, only on NASA Television.
Hi, I'm Noah Petro from NASA's Goddard Space Flight Center. The eclipse has just passed over us here at Volcano Stadium. You all in Charleston have a great show coming your way. Now, because we've got NASA at both stadiums today, we wanted to connect the two events, creating a Transcontinental Eclipse doubleheader. Now, I know Paul Hertz is there today. Paul's the Division Director of Astrophysics at NASA headquarters. Now, Paul, we've got a ball here to send your way. Now, Paul, I'm going to throw it as hard as I can. I hope you can catch it.
Great throw, Noah, but I don't think either one of us is ready for the majors. I'm here at Charleston Riverdog Stadium, and we're looking forward to a beautiful eclipse and an exciting ball game. And I hope everyone at Volcano Stadium enjoyed the eclipse and enjoys the rest of your ball game. Today is a great day for America, for baseball, for NASA, and for anyone who enjoyed the great American eclipse. Thank you.
Watch NASA Television's pre-show coverage at 12 p.m. and the entire total solar eclipse coverage through the eyes of NASA at 1 p.m. Eastern, only on NASA Television.
What we're talking about is several visualizations of the path of the moon's shadow during the eclipse in 2017. Everything in it is driven by the data. So the color of the ground, the position of the path of totality, the lighting from the sun angle, all of those are things that are based on data. A lot of NASA products were used to create this visualization. I used the Lunar Reconnaissance Orbiter, the laser altimetry data from that, which gives us a digital map of the elevations on the moon. For the Earth, I used something called SRTM. This was a radar that was flown on the space shuttle. For the positions of the Earth, the moon, and the sun, I used a JPL ephemeris. An ephemeris is just a list of positions, but it's the most accurate tabulation of those positions. This visualization is unique because it shows the effect of both the irregular edge of the moon, the limb of the moon we call it, and the elevation of the observer. Now, we've known for a long time that the elevation of the observer affects where the shadow is, and we've also known that the mountains and the valleys along the edge of the moon affect the shadow. So you may have seen on eclipse maps in the past that the image of the umbra, that shape of the shadow on the Earth, is drawn as a smooth oval. But we know that the moon isn't smooth. Around the edge of the moon, we have these sort of jagged peaks and valleys. And a peak can block the sun a little bit earlier than you thought, and a valley can let the sun in a few seconds longer than you thought. The combined effect of these peaks and valleys is to create a shape that's not really an oval, it's more like a polygon. But it hasn't actually been seen in exactly this way before, where we calculate those circumstances for every point on the map and draw that shape. Totality is that 2 minutes when or 2.5 minutes when the moon completely covers the sun. The sudden darkness of totality is just something that a lot of people can't compare to anything else. I love the idea that I'm giving this kind of map to other people, and especially that it's more detailed and more accurate so that people are actually in the right place to see it.
Watch NASA Television's pre-show coverage at 12 p.m. and the entire total solar eclipse coverage through the eyes of NASA at 1 p.m. Eastern, only on NASA Television.
Looking back at Earth from a million miles away, the Deep Space Climate Observatory will watch the August total solar eclipse in real time, giving scientists a unique opportunity to study our solar-powered planet. NASA's Earth Polychromatic Imaging Camera, called EPIC, will capture images of the moon's shadow passing over Earth. A team of scientists will combine data from EPIC with measurements taken on the ground to learn more about how the sun's energy is absorbed and reflected in Earth's atmosphere. Clouds affect how much of the sun's energy reaches Earth, which can be difficult to calculate without knowing how each cloud blocks, absorbs, or transmits light. Like a giant cloud, the moon blocks out the sun's energy during the solar eclipse. Because we already know the exact shape and makeup of the moon, scientists can use the natural phenomenon to develop new calculations that could improve estimates of Earth's energy system and answer questions about Earth's climate. NASA has studied the Sun and Earth relationship for more than 40 years. This year, NASA is launching 2 instruments to further study Earth's energy system.
Studying total solar eclipses have revealed some of the most fundamental discoveries in science today. During these celestial events, scientists discovered the sun structure, the first proof of Einstein's theory of general relativity, and the element helium 30 years before it was found on Earth. They also discovered huge solar explosions called coronal mass ejections, eruptions on the sun that continue to be an important component of NASA's research. Coronal mass ejections, or CMEs, are giant eruptions made up of hot gas and plasma. From the sun's surface, they propel immense clouds of solar material into space, speeding at up to 1 million miles per hour and carrying enough energy to power the world for 10,000 years. Sometimes they're directed towards Earth when they can affect our planet's space environment, causing space weather. Scientists track and study CMEs because they can trigger global changes in Earth's magnetic field. When intense, these can create magnetic storms that can cause aurora, but can also affect satellite electronics and power grids on the ground. Scientists discovered these eruptions in the 1970s during the beginning of the modern satellite era, a time when satellites in space were able to capture thousands of images of solar activity that had never been seen before. But in hindsight, these might not have been the first time scientists had noticed these solar features. Soon after they discovered CMEs, scientists came across reports of a total solar eclipse in 1860 that looked very similar to their satellite images. On July 18, 1860, the shadow of the moon traveled over North America, Spain, and North Africa before departing Earth. Much of the path of totality traveled over populated land, resulting in a wealth of observations. Back then, astronomical photography was still new, so many scientists recorded their observations by hand. The drawings show the large white fingers of the corona, and also a distinctive arc-like feature. With multiple images drawn from different locations across Europe, it appears to evolve over time. But not all the images showed this. About 2/3 of people saw the tulip head-like shape, but 1/3 didn't see anything at all, including renowned scientist Angelo Secchi. It wasn't until over 100 years later, with regular satellite imagery, that scientists reopened the debate about what was seen in the 1860 eclipse. The strong resemblance shows that this eclipse may be the first record of a CME. While satellites in the space age exploded the field of CME research, total solar eclipses seen from the ground still provide unique views of the sun's atmosphere that help our understanding of what causes these explosions. Current instruments in space studying the corona need to block the sun's bright body with an occulting disk. The disk covers up the sun and a portion of the lower corona, an important region that scientists believe is responsible for accelerating CMEs and forming solar wind. So when eclipses happen to fall on land, scientists take advantage of these rare events. With each new total eclipse, there's the chance for new information and new research, and the chance to reveal something as astronomical as the first CME.
And good morning and good afternoon to some across the U.S. I'm Joe Seals here at the Right Side Broadcasting Network studio in Auburn, Alabama. We are looking live now at the sun in Salem, Oregon, where the complete total eclipse is supposed to happen in about an hour and about 20 minutes or so. We have cameras, we have feeds across the country. We'll be bringing you live coverage all day from coast to coast, coverage of some of the scenes in the path of totality, and you'll be able to see cities from Salem, Oregon, all the way to the East Coast on the coast of South Carolina. So you want to stay tuned to Right Side's coverage all day. Also, we'll be breaking into NASA, who has provided a feed for the media to use. We'll be going back and forth between their coverage and feeds that we have from across the country. So we'll keep you entertained today. We'll do our best. Also, we have a crew traveling to Phoenix for the rally tomorrow with President Donald Trump. We'll be out there tomorrow. So we are covering events here at RSBN and trying to take on the mainstream media. So if you want to donate to us so we can continue to provide coverage like this, give us a email at feedback@rsbn.tv with any tips or suggestions. Share our streams on Facebook and Twitter, and you can donate at rsbn.tv/donate, or click the $ to the right side of the video, the super chat. So we'll be back in a little bit to update you, but now we'll take you back to Salem, Oregon.
Is there today. Paul's the Division Director of Astrophysics at NASA headquarters.
Okay. Yeah, I'm in the sun. Can you see me?
I can. I'm looking at you on one of the monitors.
And
yeah, I don't have my hat on yet, so it's a little bright. We have a good high layer of clouds here.
We don't. Did you need?
Moment to remind you of some very important eclipse safety tips. First of all, never, ever look directly at the sun. It's not safe for your eyes.
NASA's G3 aircraft. In the case of this aircraft, we've gone out there and taken the normal passenger windows and replaced them with optical grade windows, plus put
Glasses on if you're looking at the sun. Parents, keep an eye on your kids. Please make sure they are wearing their glasses if they're going to look at the sun. It's so very, very important today. Want anybody burning their retinas? Wow, there's a mad rush. Do we have anybody else that can hand out note cards? Volunteers, anyone? We got some note cards over here if you guys want to come on over here. And there's a basket over here, I'm told, of note cards. So you can get your note cards over. Look at this.
The safest speeds to fly.
Come on over here, get your note cards, because we're going to start playing Auntie Trivia in just a second.
We can slip the airplane.
It's fun.
That'll give us some more bank angle, which lets our cameras see a little bit higher. So all of those.
About the totality, only lasting maybe at most 2 minutes or so, but sometimes people don't realize that in terms of the entire eclipse from the very
Hey Jack, you like it? Okay. Okay, all right, great. I'm gonna pull it back a little bit.
I got somebody assigned to chase the Chris down. Not yet, so they just said, "Come this time, Chris."
Outer atmosphere.
And this year, scientists will test a special kind of
To the total density of the universe? The answer is dark energy. That's right, based on the results from Planck 2015 mission, the density of the universe is contributed 69% by dark energy.
And for each filter, there's a different exposure time. So another person has to enter the exposure time.
Running 3850 right now.
It's a combined effort of 6 different hands. No one person can make any errors.
8121. We do feel the pressure and also the excitement of the eclipse. Still, we have to focus on our experiment. Hey, all done.
It gives a tense feeling, but I believe we'll succeed.
All right, we got another beautiful shot here of Oregon, and we're getting ready to start
AKA
showing
space
you imagery
diapers.
from around the country.
Seems like a good
It's an
idea to
amazing
me.
shot.
All right,
And
our
right now,
final
we're going to
question
toss
of
it to
space trivia.
NASA Edge, who is standing by in Carbondale, Illinois.
Tell us a little bit about that, because if you've received social media questions about it, you have the data point to respond to that.
Yeah, you know,
Along its length,
This out to see these
That's right.
these sort of eclipse views.
That's
What
right.
other strategies could you share with our fans to prepare for the eclipse?
Just to basically, when the eclipse happens, spend all of your time with all the different devices and pinhole projectors before and after totality.
Pretty dark. I mean, it's the darkest blackness you've ever seen. And at that moment, you will see the corona of the sun just magically appear across the sky, and you'll see several stars today. I think we have M planets, so we have the potential to see 4 or 5, I believe, planets and stars.
Okay, but you have to be pretty strategic at that point, right?
Yeah.
Because that's during totality.
That's during
right, so you got to
totality.
get your solar experience, and you got to swing your telescope around, see, or will you be seeing them with the naked eye?
You can see with the naked eye during totality. I recommend everybody look at it with the naked eye during totality. But as soon
Inside the stadium to Kevin.
Did we lose our feed? Check that out, though. That's pretty fantastic. So we're going to play one more round of trivia. This one.
Hi, welcome aboard. We're on NASA Armstrong's G3 aircraft right above the Pacific coast. happen. We've got a fantastic look out the window right now. We're circling above Lincoln City. We got a little bit of cloud cover down there, but we're going to have a fantastic view of the eclipse, and this should prove to be a wonderful day. With me today is Robert Lightfoot, Administrator of NASA, as well as Dr. Zabukin, Head of Science. And what we're going to do is cut to them really quickly so we can have a little discussion. And
where's my
what are your
smart guy up
impressions
front
today,
to do
Robert?
all the answers? Where'd he go?
Thanks, Kevin. What a great...
He left. Oh, okay, here we go. Question number 1. Most total solar eclipses last just 2 or 3 minutes, but on rare occasions, they can last significantly longer. What will be the longest duration of any total solar eclipse this millennium? Is it A, 4 minutes 55 seconds? Is it B, 7 minutes 29 seconds? Is it C, 9 minutes 2 seconds? Or is it D, 14 minutes 31 seconds? Think about that one. Everybody got the answer? All right. On to the next question. All right, are we expecting 50 to 60,000? 200 to 300,000? 800 to a million? Or all of the above combined? Question number 5. After dark matter, most of the mass in the galaxy cluster is what? Is it stars? Is it B, planets? Is it true or false? All right, question number 8. It costs NASA an average of how many millions to prepare and launch a space shuttle mission? Is it 3.5 million, 16.8 million, 256 million, or $775 million? Question number 9 is about the International Space Station. It's equivalent to the length of a...
radiation, this perfect cloud that the moon makes affects the Earth and its turbulence. And, I mean, I'm really going to see whether we're going to feel it up here.
Very cool. All right, thanks, Thomas, and thanks for sharing everybody out there. I tell you, about 30 minutes away, we're going to measure as much as we can here, and I'm about to fight this man for a window seat. So when you get on an airplane and you look for a window seat, get your glasses on. We're going to look out here, and we're going to wrap up here from the G3 and send it back to Solar Eclipse Central. See you guys soon.
is another view of the eclipse. One of the great things about this particular eclipse, Sean, right, is that the totality will be over land for so long. So we're about to start seeing it in Oregon, but normally, you know, most times when you have an eclipse, a lot of it happens over the ocean, right? The ocean gets to see it.
Right. So for folks, especially here in the United States, this is the first time from coast to coast that we've seen a total solar eclipse since 1979. And so that's why for a lot of folks, we're talking about this being a once-in-a-lifetime opportunity. And remember, it takes about 90 minutes for the totality portion of the eclipse to cross the United States, the continental United States. So as they mentioned earlier from the G3, about 30 minutes from now to totality there, about 90 minutes to get to where we are here in Charleston. So that means what? If I'm time's right, in about 2 hours, we'll be at totality here.
And we are now going to go to Salem, Oregon, where Jesse Carpenter will be talking to Nikki Weil, a solar scientist from NASA.
You got 2 wrong. Well, you're still in the running. You can get 8 right and submit it, right? All right. Number 9. You got to get this one right. The International Space Station is equivalent to the length of a what? They're going with Boeing. I hear football field. The answer is a football field. It's 357 feet end to end. That's equivalent length of a football field, including.
Basics that you could share with us? I know we were trying to present some of that a little bit earlier in the show.
Yeah.
But are there some things that maybe you could talk a little bit about the layers of the sun?
Yeah. So there's sort of 3 outer layers of the sun. There's the photosphere, that's the part we're seeing now. There's the chromosphere and the corona above that. The chromosphere and the corona, that's the solar atmosphere. Now what's cool about today is that usually we get to see the photosphere, the visible surface of the sun. But today, during totality, we're going to get to see the atmosphere, the chromosphere and the corona of the sun. And we don't usually get to see those because they're so much less bright than the sun. It takes something special like today's total solar eclipse to be able to see them. So that's really amazing. We're going to get to see that.
It is so cool.
Let's see if we can find him. Jim Todd, there he is. Come on out here, sir.
Okay. I'm going to give you a little preview of what we're going to be seeing. We can already almost see the light is starting to change a little bit already. So we have just about almost 50% of the sun is blocked by the moon. Okay, so we're getting there. We're almost there. The excitement is really starting to grow right now. Just seeing the moon moved in front of the sun. That's the start. And so right about 10:16, we're going to have the totality. Okay? And at that moment in time, we're going to see what's called the eerie twilight. Because it starts to change.
in the path of totality and during those brief moments of totality.
Right, and Sean is stressing the glasses, but of course you can also watch the sun indirectly. There are a lot of ways. Nikki Weil, a solar scientist, just told us that you could even pull out a colander because it's got little pinholes in it. You can use a Ritz cracker that has a hole in it. The other thing is you might even see the eclipse image filtering through the space between leaves on a tree. There's some really wonderful ways of catching imagery of it. So, you know, be safe, but don't think you absolutely have to have the glasses. That is not your only option. Should we talk a little bit about the science that NASA's
We should, but
doing today,
before we do that, I just want to give a shout out to our website, because you're talking about all these great ways to indirectly view it. And again, just a plug for the eclipse2017.nasa.gov site, where you can find all kinds of information, but especially some do-it-yourself instructions on how to create some of those indirect viewing methods.
Great, we've talked a lot here about the partial eclipse. Nikki Weil, who you just heard talking, she studies the corona, that is the atmosphere around the sun. And she was telling me just the other day how excited she is that she is going to be able to see that with her naked eye during the actual total solar eclipse. So that's what's interesting. We can only see that normally from space with our space telescopes.
Right, and even with that, I was talking to one of the heliophysicists back at NASA headquarters in Washington, D.C. Recently about this, that even with those artificial eclipses that they create from the coronagraphs, they're called, in space, it doesn't give you the same viewing opportunities that we have with a natural eclipse like we're seeing now. That there's actually a couple different layers of the sun's corona. We have the outer corona and the inner corona, and because of the way those coronagraphs work, they do not allow a good image of the inner corona, the part that's really close to the sun's surface. Only the outer corona. It's only during an actual natural total solar eclipse like we're viewing today across the country that scientists, heliophysicists, and others, and just the general public are able to see the entire corona, and that really gives them a lot more information. And remember, for these scientists, no matter where they are, they only have that brief, maybe 2 minutes, maybe 3 if you're really lucky, right in the center line of totality, to see the entire corona and get those measurements.
Okay? And then we'll have another hour and 15 minutes going reverse, what we're seeing here, going in reverse.
So again, Karen, as folks are looking at their screen right now, you see that double image, Salem, Oregon there on the left, and nearby Madras on the right. 2 different images with 2 different types of telescope using to view this eclipse. It's still in the partial stages, starting to get closer and closer toward totality in just a few minutes.
And stick with us, because we are going to be tracing this eclipse all the way across the country. Not only does everybody in the country have a great view, but we have some views from the sky, don't we, Sean?
That's right. Looking up from the ground is how most of us will experience today's eclipse, but researchers at Southern Illinois University wanted a different perspective. They wanted to look down at Earth to image the moon's shadow. In Illinois and across the United States, teams are using high-altitude balloons for a unique perspective.
Right now, they're getting ready to launch a research balloon from Saluki Stadium in Carbondale, Illinois. We're going to go back to Carbondale, Illinois. The primary payload will be a real-time, high-definition video system. So let's check in on the progress of that launch.
Holistic astronomy here, we're experiencing it on lots and lots
Eclipse
of different...
in 4D. It's just like being on the surface.
But, you know, to actually understand the corona is very important, because all sun-like stars have their corona. We need to understand why the energy is released in the way it is.
All right, look, we're getting a call. We need to go inside the stadium right now. They're about to launch the balloon for the Louisiana Space Grant Consortium. So let's go to Kevin, who's standing by.
That is what's going to let that get safely down to the ground.
spaces in between your fingers.
If you don't mind, I'm gonna.
You can project little images of the eclipses down onto the ground. So make sure you look down just as much as you look up. Really see through also, if you
Right.
happen to be
Okay.
walking
My
around the campus a little
glasses
bit,
are on. Are your
underneath
glasses on
any
too?
tree, you may
Okay.
see also
And
eclipses spangled
the sun, we are turning around. Would it be okay if I turn my back to the camera so I can see the sun? Oh, okay. I'm going to turn my back to the camera. Oh my gosh! There is a small bite starting in the sun. What are your comments?
I said that is gorgeous,
because of
isn't
these
it?
ripply shapes you see on the ground.
That is
they're
fantastic.
apparently sometimes
The
referred
total
to as
solar eclipse in Carbondale, Illinois has begun. A small bite is being taken out of the sun by our satellite called the moon. This is incredible. Earlier they were telling people to talk about in one word to describe the eclipse. The word for me is majestic. A lot of times, I don't know about you, sometimes if I want to, take a break on my computer, I can take these out. I will go to the solar, I think it's the Dynamic Observatory.
Looking out toward the horizon, we await the first glimpse of a total solar eclipse when the movement of our moon completely blocks our view of the sun. Starting in the air from NASA's Gulfstream 3 aircraft off the coast of Oregon, we anticipate this awe-inspiring celestial event. Over the next 3 hours, we will track the solar eclipse as it moves across the entire United States from coast to coast, observing this incredible event through the eyes of NASA.
You're watching Right Side Broadcasting Network's coverage of the total solar eclipse of 2017. Coast to coast, we are covering this all day long. From here in Oregon all the way to the coast of South Carolina, we'll be on live for the rest of the afternoon, bringing you images and scenes from around the country. Right Side Broadcasting Network is an independent media source trying to take on the mainstream media and provide fair and accurate coverage of current events and news. We are viewer supported only. We do not take big investments from large corporations or huge donors. We are viewer supported, so we certainly appreciate any donation that you can give that helps us do things like go to President Trump's rally tomorrow, which he will be holding in Phoenix, Arizona tomorrow night at 7 o'clock Mountain Time. We have a full crew on our way there right now. 4 of us are flying in, so your donations help us stay on the air and bring you cool events like this. So if you would, please donate to us at rsbn.tv/donate. Or if you'd like, you can donate by clicking the $ to the right of your screen underneath the chat box. We certainly appreciate all of your support. We'll get you back to the action now, and we'll be changing feeds every few minutes or so you can see what this looks like. It's an amazing thing, a once-in-a-lifetime experience, so I hope you enjoy it. And wherever you are, make sure that you're wearing your glasses before you go outside.
Actually really the Apollo 8 Earthrise, and that gave us a perspective outside of just the Earth. It showed us that we were part of something bigger, and that's what this total solar eclipse brings for us. It allows us a window into the universe, and this is the most connected, most well-observed event that we've ever had in terms of a total solar eclipse. The data and the experiences are going to be amazing.
Okay, so we're certainly witnessing a monumental celestial and historical event today. We'd like to take a moment to talk about safety. So Jody, can you help me out here? So
I'll help you out.
You never look directly at the sun, and you may have seen these eclipse glasses, and they're designed with special purpose solar filters. Ordinary sunglasses, even very dark ones, are not safe for looking at the sun. Now, if you're in the path of totality, there's a short time frame that you can take your glasses off. This is only when the moon completely blocks the sun, and that is during totality. Let's watch this video to learn more. Okay, so Alex and Jody, I'm very fortunate that I have glasses, and a lot of people have glasses, but a lot of people don't have glasses. Yes. So what are other options? Let me start with you, Alex, on how they can view the eclipse
Well,
safely.
the simplest thing to remember to look at it indirectly is a pinhole viewer. And there's a lot of ways you can make a pinhole. You can take a simple piece of paper, poke a hole in it. In fact, I've got here a 3D map of the path across the U.S. with a hole in it that I can use as a pinhole to project the circular sun down on the ground, and then you can see the moon move across it. As a matter of fact, anything with holes, including this colander, is something you can use to look at the eclipse. But you can also use something a little more sophisticated if you want.
So you can actually make a box. You actually just do 2 holes in one side of the box and then put white paper on the inside. Then put aluminum foil, do a hole in the middle, not too big, that you can actually project the sun inside the box. Make sure that the sun is actually behind you so you can actually look at it inside of the box. It will be an amazing projector.
Okay, so before I toss the social, I got to do this because we're on the College of Charleston, and College of Charleston students, make some noise! That's what I'm talking about. Okay, so the social media world is going to break records. So let me toss to my man, John, on the social front. What's going on?
Thanks, Dwayne. There are literally millions of people watching this broadcast right now. We're going to be monitoring the conversation online and taking your questions as a total solar eclipse treks across the United States. There's a tremendous amount of excitement online, and we want to share with you at home. So we will show you images of the eclipse from your unique vantage point. Submit your pictures and questions using the hashtag Eclipse 2017 and follow the conversation online. For updates, be sure to follow, let's see if I can remember all these, NASA on Facebook, Twitter, Tumblr, Instagram, Snapchat, and LinkedIn. Additionally, we're providing live coverage during the eclipse on Facebook Live on NASA's Facebook page. You can ask your questions in the comment thread. Check out their streaming sites like NASA's Periscope account on Twitter, Twitch TV, Ustream, and on YouTube. And of course, you can watch it on nasa.gov and nasa.gov/Eclipse Live and on the NASA app. And we have a special feature for you. If you visit our Facebook Live page, along with this broadcast, we have a 360 view from right here in Charleston, South Carolina. With this tool, you can pan around on your computer and mobile device and even look up to the sky as the moon transits the sun during the eclipse. It'll be like you're right here with us in Charleston, minus the sweltering heat. Visit the NASA Facebook page and check it out. And finally, share your images of the eclipse with us using the hashtag Eclipse 2017 on our Flickr page, which is up here online right now. Share your images with us, and we'll share them right here in the broadcast and also on social media. And finally, enjoy your eclipse viewing, and remember to ask your questions with the hashtag Eclipse 2017. Back to you, Dwayne.
Well, John, it's social media is going to break some records, and we're going to be coming back to you more and more. So you got to know that one of the most important things here for today is the weather. So, Sean, you know, I'm looking at Charleston skies. We got clouds. I hope that's going to get better, but what's going on around the nation? Over to you.
That's right, Dwayne. Yes, the weather is the key factor for viewing today's total solar eclipse. Right here in Charleston, it's about 86 degrees, but with the humidity, it feels more like 99 right now. But what we want to do right now is show you a
Now I had to turn down my filter.
of these coronal mass ejections leaving the sun during a total solar eclipse.
Now, why is it so critical and so important to really get this type of view from the sun's atmosphere from the corona? Johnny?
You mean like in a total solar eclipse?
Yes. Oh, there's the diamond.
That's
There
the
we go,
diamond ring
diamond
again.
ring.
That's amazing. That's from Madras.
Wow.
It is important to do this because we do this kind of eclipses artificially, but we do not do it as perfect as nature does. The moon covers the sun in such a perfect way that we see parts of the corona that we don't usually see.
So Alex, explain that and safety too, right?
So right now, this was the moment when you see that flash of light. That's the moment when it's time to put your glasses back on or start using your indirect methods, because now it's too bright and it could damage your eyes.
Yeah. Safety first, people. Always.
Wow. So the folks in Salem, Oregon, I mean, they're like juiced. I mean, they got it. They got the good.
They've got a perfect view, and they are seeing one of nature's most amazing spectacles.
I can only imagine the reaction on the ground from the folks there.
Oh.
International Space Station coming up and other images only we can bring.
Only NASA can bring, yes.
Now, is it completely dark or is it coming out?
No, what's happening now is the filters are back on, the safe solar filters for the telescope, and now you see the crescent, which is the sun, basically now being revealed after the eclipse. So we're now back to the partial phase in the other direction.
Exactly.
Now, how fast is this going?
Well, this shadow is passing across the country, depending on where you are, anywhere from 1,200 to 1,800 miles an hour. So this is moving incredibly fast because the moon itself, in its orbit, is moving at almost 3,400 miles an hour. And that, in combination with the rotation of the Earth, is what gives us a shadow moving that fast.
Okay, so Gotti, let's talk about space weather. Seeing this and space weather is so important. So just let us really understand why it's important on space weather.
So space weather is pretty much the conditions created outside in space due to the sun. We look at space weather because we want to understand these conditions. If you look at the image that you have now, you're going to see SDO image, the Solar Dynamic Observatory. That's where we actually look for the source of space weather, where the solar flares and the coronal mass ejections actually originate from. Well, when we look at SDO, at the images, we also have to look at artificial eclipses, like the one that you're looking at online now. These are actually from the SOHO spacecraft. These are the artificial eclipses that I was talking about, Dwayne. Like this, you have to block the solar surface to be able to see the solar atmosphere, the outside corona. But you're gonna see something like this today, and you saw it. But you're gonna see it better because nature does it better than we can actually do it artificially. Right now, the activity is there's not too much going on in the sun. However, if I do a historic event, which actually was from this past July, you can see a coronal mass ejection, this big explosion of particles that come from the sun.
Well, those look pretty intense. Do we have to worry about that? That doesn't look good.
Well, you know, space weather, what can actually do is affect communications. We have the magnetic field of the Earth to actually protect us. It's our shield. And what we do is we actually can analyze that using real-time models like the one that you're seeing on the screen, that we actually understand how the magnetic field of the Earth changes with those coronal mass ejections. But space weather can affect communications, satellite instruments, and power grids.
Okay, so we're going to toss to Idaho. And I think we've really got some good stuff here. Gay Hill, are you there in Idaho Falls?
I am absolutely here, Dwayne Brown. In fact, looking through the glasses right now, it's so weird. We have a crescent sun instead of a crescent moon. this is the, I think we haven't had a total eclipse here in Idaho Falls since 1889, 128 years ago. And things have certainly changed in Idaho Falls since then. There's a whole lot more people, especially with all the visitors in town. We're just outside the Museum of Idaho, and we have partnered with the museum to make this an official viewing site for Idaho. And they right now have an exhibit on space, but we also sent in a team of experts. And for the past 3 days, we've had talks, we've had demonstrations, we've shown them visualizations such as eyes on the solar system, and we've shown them artwork. But really, the order of the day is the eclipse, and NASA has that covered too. They have sent an army of volunteers. We call them solar system ambassadors. They are all along the path of totality, and they're volunteers. These are people just telling people what they're seeing and helping them understand. We have one here, right here. His name is Richard Stemper. Hey, Richard. He has been manning this mobile observatory, and that is what is providing our solar telescope shot right now. Now, we asked him, what's it like being a solar system ambassador? And he said, follow along. We did, and we went with him to a school in Southern California. Take a look. All right, we apologize. There is no audio on that video, but it talks about the solar system ambassadors. There are about 720 in the United States. They get special training from NASA. They learn all about the missions and about the science, and they basically go out to public events all over the country teaching them about NASA missions. If you would be interested in becoming a solar system ambassador yourself, you can. We have a website. Look it up, Solar System Ambassadors. It is a NASA website, and starting September 1 through the end of the month, you can sign up to be a solar system ambassador. So check it out on the web, Solar System Ambassador. With me now is Jim Green. Jim Green is the head of planetary science for NASA. He's in charge of all planetary missions and asteroids. This guy knows his stuff. Let's talk about this. Now, you see this eclipse that doesn't happen. It happens once in a lifetime.
Wow.
But as a scientist, you see it as an opportunity.
Oh, absolutely. I mean, we're getting the eerie feeling right now, but when we launch balloons, and there'll be 57 balloons along the path, 30 of which are going to have a planetary experiment on them.
And we have video of this. Now, just a few days ago, we had a crew here. They did a test launch for us, and they sent up an imaginary payload for us just to see how it all works. You have actual scientific experiments going up.
We do. We have a bacillus. It's a harmless bacteria. We have on 30 balloons 2 coupons where the bacteria will be sprayed. One will stay on the ground, one will be affixed to the balloon. It then will go up to 100,000 feet above the ozone. So the ultraviolet light, also blocked a little bit by the moon, is just like Mars. In addition to that, the temperature and pressure will be just like Mars. So when the balloon goes up higher and bursts, comes down, we'll retrieve that coupon off the balloon, match it with the one on the ground, and then we'll see how many survive.
Now, why is that information so critical for Mars research?
Well, this bacteria is pretty much everywhere. It's very hardy, and it probably has made its way to Mars, perhaps even on our rovers. And I would like to know if that environment is so harsh that it would eliminate that bacteria or not.
All right. I'm being selfish. I have never seen a total eclipse. And I'm sorry, I would love to talk to all of you people, but I want to put on my glasses too.
One minute away. Wow.
The crowd is getting excited.
Wow. It's already so
Oh,
eerie.
wow, it just got dark all around us. And you can feel the temperature getting colder
Oh,
here.
yeah. The winds are really picking up. You know, this dark area, the winds are just flowing in.
Oh, you can, it's just a tiny, tiny sliver right now. It's all closing up.
There it goes. It's going. Getting smaller.
Oh my gosh!
Oh, look at the ray structure. You can't get that on film. There's Venus.
Oh wow!
There's Venus. Oh, wow. Wow. Oh, look at that ray structure.
You were saying this is the only way you can see the atmosphere.
Yeah, that lower part of the corona is really even hard from space to see. Wow. Wow. I got to spend a second looking around at the crowd. Oh my goodness. Yeah, wow. Wow.
We should turn off the lights.
All right, have to get ready to put them back on here soon.
Okay.
Pretty quick.
Have you noticed, Jim? The street lights are all on
Oh, the
around
street
us.
lights turned on,
We
of
confuse
course.
the street lights.
Of course. Who would have thought that? We didn't plan that one.
All right, we should get ready for our glasses again. Get ready with your glasses.
Okay, there it goes. There's the diamond ring. There's the diamond ring.
Oh my gosh.
Yeah, wow.
That
Wow.
is
Was
so...
that all right?
Oh my gosh. Whoa! Oh, that's brilliant.
All right. Wow.
Okay, glasses back on.
Wow. Too brief. Too brief. Too brief.
Okay. We're going to have to wrap this up pretty soon, Jim. That was incredible.
Way too brief.
Yeah.
Way too brief.
We got a minute 50 seconds.
Yeah.
That was all we had. Why is it that some parts of the country get a little more than we do?
Well, it has to do with the curvature of the Earth also. And so the shadow is at various altitudes. You could go up at a higher altitude and get also a great view too.
Well, this was a real treat. This was fantastic. So Idaho Falls has had its total eclipse. The next one is coming in 2252. We won't be here, but we hope NASA will. Back to you.
Well, Gay Hill, that's Gay Hill from NASA's Jet Propulsion Laboratory. Gay, I'm jealous. I'm telling you, I'm jealous. So Alex, explain again that diamond.
Well, so the last bit of sunlight, when you see it at the very beginning, is when the last bit of the sun, the crescent, shrinks down to a little tiny bit. And at the same time, you can see a ring of the corona around it, so that makes the ring, and then that bright bit of crescent gives you the diamond. So when it reappears, you get the same thing. The last bit of corona is a ring. The flash of the sun is the diamond, giving you the diamond ring. It's a beautiful, beautiful sight.
And real quick, and then I'm going to ask you a question because there was something going on here in Charleston. The planetary, Jim Green said something about Venus. This is really cool for planetary science because you can see other planets, right?
Absolutely, and as a matter of fact, one of our missions through the WB-57 aircraft are studying Mercury, which is very, very close to the sun.
Okay, so we're gonna come back to you and we're gonna talk about what's happening here. So the next up, NASA's ready to take a bite out of the Big Apple, one of my favorite cities, Jody, New York City. New York City. Today's broadcast is being shown, I believe, in Times Square on the Toshiba Vision screen, so the city can also enjoy the spectacular views of today's total eclipse. And we've got a great relationship with Toshiba, so a shout out to you guys. This Midtown Manhattan tourist location is always bustling with crowds. On the average day, over 300,000 people pass through Times Square. Alex, I'm gonna turn to you. You know, New York, they're going to get a partial, but they have a rich history in solar eclipse.
They really do. So actually 92 years ago, on a cold January morning, New York City, Manhattan, and Queens experienced a total solar eclipse. The edge of the path of totality went from 95th Street to 97th Street. This was an amazing opportunity. This was the first time we sent up 2 dirigibles with the U.S. Naval Service for scientists to study this. At the time, we actually thought eclipses could be creating radio waves which mess with communication. But what in fact is happening is the sun itself is creating this disturbance. So studying the eclipse is actually telling us about the sun, which is creating these disturbances here on Earth.
Yes.
Okay, so this just in. I believe we have results from an experiment that occurred on NASA's Gulfstream 3 aircraft from NASA's Armstrong Flight Research Center. Karen Rohr is standing by with Thomas Zabukan, the Research Administrator for the NASA Science Mission Directorate. Let's go now to see what the instrument observed during the total solar eclipse. Kevin.
And we're back here at the G3 up over the Pacific Ocean off the coast of Oregon. And it was amazing, wasn't it?
It was outstanding.
And so for me, like, you know, at 25 years I did research on the corona. I saw it for the first time. It was my first eclipse. Was it your first eclipse?
My first eclipse as well.
Just absolutely amazing. And I want to talk about 2 things. First of all, the shape of the corona. You know, I saw the models. I showed the model, and it was remarkably similar. You know, I saw these streamers, these magnetic structures coming out like glows in specific directions, just like we expected. So I'll look for the analysis before we claim victory, of course. But the other one is that spectral you, Mike, you know, ran on board. And just before that the sun, you know, disappeared behind the moon, that spectrograph, of course, is spreading out the light in all its colors. Just before it disappeared, there is that one shot. And Laurie, I want to ask you whether you can turn it on. Do you see those specific kind of lines that pop up between the green and the red? It's just like we said, it's helium. Remember, that's how it was discovered, helium. We didn't know we had helium here. It was a new element. It was discovered that way. And then over there in the red, between the green and the red, is iron. Iron, a really hot iron, telling us that, hey, this atmosphere is really hot. And then a little bit over, it's another line, red. Well, what is that? That, hey, this atmosphere is really hot. And then a little bit over, it's another line, red. Well, what is that? Well, it's hydrogen. Well, so even though it's really hot up there and only one, and so Robert, back to you here. Back on Earth, what did you feel like? How did you? So Robert, back to you here. Back on Earth, what did you feel like? How did you?
Underneath us, we're at 35,000 feet. on the ground level of Earth from 35,000 feet was amazing. I just got to tell you, the team on this plane and the team all the way around this country is just doing a fantastic job. I wish you could have seen that we've already looked at that I can't wait to share with everybody and for everybody to see. But we've already looked at that I can't wait to share with everybody and for everybody to see. But really exciting to watch this team work, and the pilots did a great job. We had a little bit of a challenge right at the time of when we needed to be best, but they did a great job recovering from that, and then kept us on path all the way through. So anyway, so thank you guys. Remember to put your glasses on for those of you who hadn't seen it yet, and we'll talk to you soon.
Fantastic stuff. And if you just tuned in here, you're watching Through the Eyes of NASA, NASA television. We have the best views of the solar eclipse today and coming later in the show. You don't want to miss this, the International Space Station live. Now, next up, let's visit a working farm at Austin Peay State University in Clarksville, Tennessee.
Thousand feet, which is higher than any plane has ever gone. We're also flying some biological samples with NASA Ames.
High altitude balloon launches and painting.
We're also flying some biological samples with NASA Ames and then our trackers so we can have a successful recovery.
Okay, and they've just released your balloon. So let's talk about the NASA science and the biological samples. Explain more.
So NASA Ames has contacted us and all of the other teams that are going to be doing launches today across the whole path of the eclipse. We're going to all have a little chip of biological samples on there that are going to go up in the stratosphere, which is a similar atmosphere as we would see on the Martian surface. So we're doing some Martian studies, which is really interesting and cool.
We are very excited about that. And so also, how many balloon releases are you planning on doing this today or this weekend?
So all across the U.S., we have about 50 teams that are launching in the path of the eclipse so that we can have a full coverage of the stream. And on the site today, we have 3 launches from 3 different universities. And we're just really excited to be here and hopefully all successful launches.
All right, so finally these balloons do go up and they come back down. And so what's some advice if anyone finds one of these payloads out and about across the country, what's a tip you would tell them?
If you find it, leave it there. Maybe take a picture because it's kind of cool to see something land in your backyard from research. And please don't touch it. We'll be there soon to pick it up. If you have to move it, let us know, and we'll just be there to recover it.
Awesome. Thanks. We appreciate your time.
Thank you.
Appreciate it. Okay, so yesterday we had a chance to catch up with some serious students, albeit a little younger, but serious about doing real-world science nonetheless. And here to tell us more is my good friend and colleague, Mitzi Adams from NASA's Marshall Space Flight Center in Huntsville, Alabama. Mitzi, thanks for joining us. We appreciate it. So tell us about the science that these high school students are working on.
Well, the students are actually working on some atmospheric science experiments. They're doing animal study experiments, and they're helping us observe the sun in various wavelengths of light.
And these students aren't just from the Clarksville area. I understand they're all around the country, if not perhaps the globe.
The students are from the U.S. Space and Rocket Center, and yes, they are from all around the globe. And they're actually from the INSPIRE project as well. They're participating in VLF radio noise experiments, and those folks are from Washington, D.C.
All right, excellent. And so you mentioned the Space and Rocket Center, Space Camp. That's the official visitor center for NASA's Marshall Space Flight Center. Feel free, if you're in northern Alabama, to come and see us. They do a great job of representing a past, future, and present history of NASA. So any parting words?
Well, you know, in the words of Frank Reynolds, I'd like for us to remember for the next American eclipse in 2024, let the shadow of the moon fall on an earth at peace.
Very poetically done. We appreciate it. All right, so up next is, as promised, our animal lovers segment. And so here on the agricultural farm, students are studying really cool STEM fields. So it's conservation management, it's veterinary medicine, animal biology, and so they're interested in animal behavior. And so joining us is Dr. Donald Sudbrink, head of the Ag Department here at Austin Peay State University. And so it's not cow tipping, it's cow painting, correct?
Yes, we had to paint the cows that are in this study to see what sort of things that they would do so we could record the individual animals so we could see what behaviors that they were exhibiting.
So we saw the cows, and the students were involved with that Mitzi just spoke about. And we're also talking about cricket behavior and cricket observations.
Yeah, yes. Well, we're also talking about crickets. I'm an entomologist by training, and crickets generally chirp at night. So we're going to get a chance to see a series of isolated males and see what they do when the sun goes out.
Okay, excellent. Well, glad you all are doing this kind of observational research. Really appreciate your time.
Thank you.
Thanks a lot. So, and speaking of time, it's almost time for us, everyone here at Austin Peay State University, to actually watch the solar eclipse. So let's go back live for continuing coverage of NASA's eclipse across America from Charleston.
Okay, so Yadi, I wonder if the milk tastes better when you paint the cows. I don't know.
I don't think so. I don't think so.
All right, let's go to social media. We've been in the show here, and I know it's a buzz. So over to John Yurbrick for social media update.
Yeah, last time I looked, Dwayne, there were 2.1 million people looking online on our website, on our 1.2 on our live stream. So it's a huge conversation, and Solar Eclipse 2017 is still trending #1 on Twitter. So it's been huge. Can we go to the first slide here that I've got up? This right here is an amazing photo. Sometimes they say you have to be at the right place at the right time. This is taken by one of our NASA photographers, Bill Ingalls, out in Washington. And he captured, it's hard to see here in this pic, but he captured the International Space Station transiting the sun during the partial eclipse there in Washington. Pretty amazing. You kind of have to look closely. We'll also be putting these images up online if you want to see them. But one of those little dots there is the International Space Station traveling at 17,500 miles per hour. Here's another one from our photographer in Wyoming. Same concept, capture the space station. We knew exactly when the space station was going to be flying, what its orbit was, and when it was going to cross the sun. And look here, it's just an amazing sight. I'm really proud of our photographers for getting these shots and proactively trying to get something that no one else probably has and thinking through and getting this great image. So let's take a few questions from social media. I want to remind our viewers at home that you can ask questions to us here on the set and on social media with the hashtag Eclipse 2017. So why don't we bring it back here to the stage. First question is from Twitter. What if we wear sunglasses instead of eclipse glasses? Will we actually be able to see the eclipse? The sunglasses help? Does it give you any sort of protection?
No, that's definitely a no-no. You should not wear sunglasses, normal sunglasses. Always wear the actual sunglasses that are made for solar viewing, like the ones that I'm having here right now in my hand. And if you don't have the sunglasses, you never look directly at the sun. You look like you do an indirect projection of that eclipse. Never look at the sun without the proper safety.
So another question here comes from Deborah from Facebook. So the sun rises in the east and sets in the west, and the Earth rotates in clockwise motion. Please explain how it starts in the west and ends in the east.
Well, so the Earth is rotating from west to east, but actually the moon is moving faster, about 3,400 miles an hour, casting a shadow down on the Earth, which is rotating about 1,700 miles an hour. And that actually means that the shadow is moving from west to east across the Earth at about somewhere between 1,200 to 1,800 miles per hour, depending on where you are on the Earth.
Okay, great. We have another one. I think we have time for another one. Tina from Facebook's asked, if I place a lens from the eclipse viewing glasses over a viewfinder on my iPad, could I successfully video the eclipse, or would it fry my camera?
Yeah, you can actually look with the iPad or your phone to the eclipse. The only thing is, you have to be very careful not to look at it with your own eyes without the actual safety glasses. Never look at it through any lens.
Okay. This is Mickey from Facebook. Hey, NASA, can the International Space Station see the shadow of the moon crossing America from space? Do they have that view when they're looking from space?
They do, and that's what we're hoping to see from them, yes.
Excellent. So, John, we're going to come back to you. So I think we're going to go back to Sean, our meteorologist. Let's learn more about how NASA is studying the Earth and Sun relationship during this eclipse. Sean, can you tell us more about that?
Right, thanks, Dwayne. So during the eclipse, the moon acts like a giant cloud as it passes over areas in the path of
Welcome.
Dwayne, thank you. So happy to be here.
Oh, it's an exciting day.
It's a
I'm glad
wonderful
you're
day.
to join the team here. And our next location you are pretty familiar with, I'm sure.
I'm very blessed, and I do know something about the great state of Nebraska. I've actually lived there for the last decade, and I have friends and family who are watching there from the Path of Totality. I have to tell you, this is by far the biggest thing that's happened in Nebraska as of recent. It's absolutely fabulous. I have had friends from high school and college calling me up, Facebook messaging me, asking where they can get their glasses, where they should be viewing from. So it's just a really exciting day for everyone who's watching along the Path of Totality. It's also a really exciting, and in fact, this gives us an opportunity to look. We are going to be doing the spacecraft next year, probe, and it will fly directly into the solar atmosphere. The mission will first of its kind data, and for more information on this future mission, let's go to Beatrice, Nebraska, where Vince Whitfield from NASA's Langley Research Center is standing by. He's at Homestead National Monument, where the National Park Service has coordinated an eclipse viewing. Vince?
And just in, I think we're having, Vince is going to come up shortly, Jen Ray, so we're going to go back with an image, but we will be doing Nebraska as soon as we can. So a shout out to the great state.
Thank you. Worth a shot.
Okay, folks, Jody and Alex, this is a different view here. What are we seeing, Alex?
Well, so we're looking at a different wavelength of visible light. It's called calcium K. So this is light that's produced by excited calcium. And this is showing us the sun as the moon is moving over it. In fact, if you look over on the edge of the sun, sunspots, like myself and Jari are most attracted. That's where solar originate from. In fact, the corona sunspots.
Actually, this sunspot had a
Right, and I believe this is coming from Carbondale. So that's now it's why is it purple? Is that what's the color?
That's actually the light and bluish light, and so it comes out as a purple color. But it is a type of visible light. It's one we look.
Hopefully we get Nebraska. Okay, Sean, we're going back over to you. We'll talk about moon shattering.
Wayne, we've got some really incredible imagery for you. This is again from the GOES-16 weather satellite just launched last year by NASA for our friends at NOAA. And what you're seeing in the western portion of this image is actually the moon's shadow being cast over parts of the Path of Totality. And of course, you see the cloud cover across the U.S. as well. And as I was telling you earlier, it's actually looking pretty good for most of the western parts of the U.S. that are in the Path of Totality. Not so good for maybe parts of the central U.S. Where we've got some thunderstorm activity developing and expected to develop later today, this afternoon, for places like Nebraska, parts of Nebraska and Missouri and northern Illinois, so maybe north of Carbondale. And then gets better again as you see in terms of cloud cover as we move further east toward Charleston here. But here in Charleston, we still have some breaks in the cloud. Where the sun is, it's still obscured, but we are able to actually see some of the partial eclipse here in Charleston through some of the breaks in cloud. But again, really wanted to show you guys that imagery from GOES-16 satellite from NOAA showing you the moon's shadow actually being cast over parts of the western United States right now. With that, Dwayne, I'm going to hand it back over to you.
Thanks, Sean. Now, as a reminder, our broadcast is tracking the total solar eclipse as it crosses the United States. It's moving along a path of totality. That's a 70-mile wide path sweeping across the entire nation. Over 12 million people live inside the path of totality, plus it's estimated that close to 7 million people have traveled to cities within the path of totality. I know that today is truly a day of celebration as people gather in cities and festivals to view today's celestial event. So let's get into the cultural impact here, guys. Alex, what's your take on the cultural impact of these eclipses?
Well, you know, this is really such a fantastic opportunity to connect the nation and, in fact, the world with one of nature's most amazing celestial events. And this is something that we, as working at NASA, are really excited to be able to share. And in fact, we've even worked with some of our colleagues in other parts like the U.S. Postal Service.
Yes, the U.S. Postal Service actually created a special stamp for this event.
Right. So what I want to do, let's talk about the stamp.
Sure.
But Jen Ray Thompson, Nebraska, the sunspots are gone, so let's go to Nebraska. Vince Whitfield, are you there?
Hi, we're at the Homestead National Monument of America. This is a great location to watch the eclipse, and we've staked out a good spot here on the prairie. Even though the weather isn't cooperating, this is still an excellent event. We're also very prepared. Please make sure to use your protective glasses when viewing the eclipse wherever you are. You can cause serious damage to your eyes if you don't take precautions while watching. And there are a lot of people watching. As you can tell, the festivities, just like the eclipse, are in full swing. I'm joined by Chief Park Ranger Susan Cook.
Hey Vince, how are you?
Great, Susan. Thanks for joining me today. Please tell us about this amazing place and what's going on behind us.
Well, we are at Homestead National Monument of America. We are a national park site dedicated to telling the story of homesteading. 30 states, 4 million people, 10% of the United States was homesteaded. The head of a household, anybody could own land as long as you could be a U.S. citizen. You got 160 acres. It's how we settled the West. We built our democracy, we built our economy, settling the West through this law.
That is just so interesting. Now, I understand the Mayan followed the solar eclipse calendar closely. Is that correct?
It did. The ancient Mayan used several different calendars to organize their secular and spiritual lives. Many of these calendars had strong roots in the motions of celestial objects, especially the sun and the moon. And the Hub calendar is a solar calendar of 365 days, subdivided into 18 months of 20 days, plus 1 month of 5 days. Another calendar is a Tzolk'in made of 260 days, subdivided into 13 months of 20 days. This calendar also has a resonance with eclipses, which occur about every 173 days. Every 3 sequences of eclipses aligns every 2 cycles of the Tzolk'in. Who could keep track of that, frankly?
It's just amazing. Now, as a Chief Park Ranger, I have to congratulate you. This is a fantastic venue. Tell us about some of the activities you have planned.
Well, actually, right now you can feel it getting darker, but we have stage performances going on. We have many NASA scientists. You can learn about planetary defense, how do we defend our world. You have NASA scientists doing other things. We have Native Americans. We have a Mayan Calendar in the Sky program. We have folk music. We have all sorts of fiddle music.
Lots going on.
Lots of things, balloon launches. So there's things all around us. It's really exciting and a lot of fun.
Got to say, the amount going on here, Susan, is incredible. Thank you so much.
Thank you very much. Thanks for being here.
Absolutely. And we're lucky enough to be joined by a real NASA scientist. Let me introduce you to Dr. Nikki Fox.
Hi, Vince. How are you today?
Great, Nikki. Thanks for joining us. Nikki is a space weather expert and a mission project scientist on NASA's Parker Solar Probe program. Thanks so much for joining us, Nikki. Today is a great day for you. Tell us why.
Well, today I'm really excited. This is my first ever solar eclipse, and it's the only chance that we can see the corona with our naked eye. And I'm particularly excited because I'm working on NASA's Parker Solar Probe mission, and we are going to fly into the corona. So if the clouds clouds part here, you'll be able to see where our mission is flying.
That's just incredible. Now, how close will you get to the sun?
We will get to within 4 million miles, and I know that doesn't sound terribly close, but if I put the Earth and the sun apart on a football field, then we would be at the 4-yard line.
That's just amazing. Now, for you watching at home, that's kind of like traveling from Washington, D.C. to Philadelphia in about 1 second. Just incredible speeds. Now, how can you be so close to the sun and not burn up?
So we have a wonderful heat shield, but we also, the technology, it's been 60 years since this mission was first thought of, and it's only now that technology has caught up with our dreams.
That's just amazing. Now, it looks like we're coming up to the moment of totality here on the prairie. What are some of the things we should be looking for?
So if it clears, you should see a beautiful corona, and that it looks like a pearly, hazy crown around the sun. And in fact, it's called a corona because that's Latin for crown. And then as it's going beautifully dark here, it's becoming twilight. You hear everyone going crazy here. You should be able to start seeing stars, and we can actually see 4 planets. This time you should see Jupiter, Mercury, Mars, and Venus all in this night sky during the day. So it's just an amazing, amazing experience. And if you can't see the corona, I do have a map of it here. This is a 3D print that was done for me, and it looks exactly, it's a predict of what the corona looks like today. So if it's cloudy, here's your corona.
Now, it looks like the moment of totality is upon us. Let's just take let the guys at home have a few moments to take in the sights and sounds of the crowd as totality happens on the prairie.
Oh, wow. And you can see the corona, and I may cry, but you can see the corona. So now you're seeing this wonderful hazy atmosphere. I don't need my glasses now, Vince, because we are in totality.
Wow.
And so this is the only time that it's safe to look. But right now you can see that hazy ring. That is the chromosphere. It is looking a little bit sort of reddish. And you just see there's those red wisps are little prominences that are coming away from the sun.
Wow.
Unfortunately, we can't quite see the stars yet because of the clouds. But my goodness, you can see the corona, and that is an absolutely incredible, incredible sight.
Yeah, this is just magnificent.
It really is. Everything's kind of, well, other than the people hooting and hollering here, everything else has gone quiet. The animals think it's nighttime. There's this amazing sort of twilight view all around us. And just look at that corona. That is incredible. Absolutely incredible.
Yeah, that's amazing.
Yep, and the moon is going to continue. We've got about 2 minutes, 35 seconds of this amazing view. And then here we come. Here comes the diamond ring. So it is glasses on again time. Glasses on. And here it comes. There's the diamond ring. And that is the most spectacular sight.
That's amazing.
That is just incredible. And of course the diamond ring you see because the moon is not a totally smooth sphere. And so you're seeing little spots of light peeping out between the craters on the moon. And my goodness, I'm sorry, I'm so excited. It's incredible.
Yeah, it's hard to convey the excitement of the energy. There are 10,000 people on the prairie here at the Homestead National Monument of America, and the energy is just amazing.
And they've been here, a lot of them have been here since 6 o'clock this morning, and the atmosphere has been incredible. Everybody is happy, and it has just been amazing.
That's just amazing.
Wow.
Okay, Nikki, let's bring you over to this side. It looks like the moment of totality has passed us here.
Yes.
Now, what should we be watching for in the moments after totality?
In the moments after totality, you will start to see again the Bailey's bead. So we did see that diamond ring, and I got super excited. But as the moon continues now to pass away, you'll start to see the solar surface come back. It's becoming light again. If we had any roosters here, they would actually be crowing. So it's just been, it's amazing, and you'll start to see the sun coming back. And I don't know, I always think what it would have been like if you didn't know the sun was going to come back. You just thought it was disappearing, but here comes the sun again. So it's a wonderful, wonderful day here on the prairie.
That's wonderful. Nikki, what an amazing experience.
Yes.
Thanks so much for talking us through that.
I wouldn't be anywhere else, Vince. Thank you.
Thank you very much. What a great experience, everybody. That is amazing. Now, it looks like things are starting to calm down here on the prairie, but that doesn't mean the show is over. Our coverage of the path of totality continues across the entire path. So, let's go ahead and send it back to NASA's Eclipse Central.
Thank you, Vince. It was well worth the wait, my friend. We were a little delayed there, but my goodness. Jody, did you see that? I mean...
That was amazing. Do you see that diamond ring?
that was, you know, it was even more prominent there.
It was very prominent. You could see like the ray of light, like very, very nice, and the whole diamond around the whole surface. It was amazing.
And Alex, it got really dark. I mean,
it really did. That's actually enjoyed seeing them out on that prairie and seeing. It looked like she was in some sort of weird, strange light, and she was lit up, and everything behind her was dark. It was really cool.
Fantastic. Nebraska, you rocking the house. We really, really appreciate that. But like Vince said, there's a lot more to come, and we got the International Space Station, don't forget. So, Johnny, I want to go back. You know, we had to bring in those images, but we were talking about, and you mentioned the stamp. Now, the United States Post Service, they do amazing work.
They do.
But they really outdid themselves this time. Go ahead and finish.
They did. They actually created a special stamp for this event. It's actually a thermochromic stamp, which means that it gets activated by heat, and you're actually looking at it now in your images. This stamp, if you put your thumb into the center, it will actually make the moon surface appear, or any type of heat that you apply to it. It's an amazing stamp, and you know, I got mine yesterday thanks to Dwayne.
And it's thermochromic?
Thermochromic, yes.
Yes. Oh, wow.
It means it gets activated by the heat.
Yeah, heat of your thumb, and I bet you they sold a lot of those stamps.
Oh, they did. They sold out online originally right away. So it was quite a popular one. It's the first time the U.S. has ever used that type of ink.
Okay, so we have seen some pretty cool images. Still got some more to come.
Yeah.
The diamond has been prominent. Let's go over to social and see how things are going. John.
Thanks, Dwayne. We're continuing to look up here in Charleston, South Carolina, because there are some clouds here, and we're excited. Excitement we want to have here too as well. Just a couple quick interesting things. This is the biggest live stream event ever measured on NASA.gov. The web traffic is accounting for 87% of all federal web traffic, which is pretty amazing, showing that people are really, really tuning into our broadcast here. As of 1:40 p.m., 4.4 million people in climbing were watching this broadcast. So the interest across the country is obvious here, and we're going to continue to show you some amazing live views. This one right here is, again, another photo of the space station taken by Bill Ingalls in Washington, one of our photographers here at NASA. Next thing, I have a video from another photographer, one of our other photographers, as the space station transits. You can see it there. If you're looking closely, you can see the space station transiting the sun during the partial eclipse. Pretty spectacular. Again, that's 250 miles per hour, that space station. And you have to be, 250 miles above the Earth, 17,500 miles per hour. You have to be taking a lot of different shots pretty fast to capture that. So nice job, Joel.
Okay, so let's go to Jefferson City. The moon shadow is continuing to pass over the United States in this remarkable celestial event. Our next stop on the path, as I said, of totality is Jefferson City, Missouri. We're going to hand off to meteorologist Eric Aldrich, who is a professor of atmospheric science at the University of Missouri. He has some special guests to help explain two important impacts solar activity can have on humans and the technologies we use. Over to you, Eric.
Okay, thanks a lot. Yeah, we are live in Jefferson City, Missouri. Jefferson City is actually the state capital, and as you can see behind me, there's a lot of people that are here. It's been a whole weekend type of thing, Saturday, Sunday, and of course here on Monday, lots of family-friendly things. There's been corn mazes, there's been 5K runs, there's a lot of good food. Too bad you can't smell the food, but there's a lot of good food that's here as well, and just a very nice weekend. The weather has been perfect. We've had some showers and thunderstorms off to the west all morning. We've had a few high clouds kind of stream on in, but certainly things are looking really good. I am lucky to be joined here by two special people that are going to be talking about space, weather, and just how things work in space. Dr. Janet Kavandi, thank you so much. You are the director of the NASA Glenn Research Center in Cleveland. Right. You're also a three-time shuttle astronaut.
That's right.
And you're actually from Springfield, Missouri.
I
so.
am.
Welcome home.
Thank you. It's great to be back.
Well, great.
Yeah.
So now, we've been talking a lot about safety, and obviously you don't want to look right up at the sun.
Not without these.
That's right.
Right.
And so we all have some, so that's good. But what about the astronauts that are up in space?
Mm-hmm.
What is there to help keep the astronauts safe from the solar radiation and so on and so forth?
Well, for their eyes, we know that they know that certain windows they should not look out of because there's no protection. Other windows have protection on them that help shield their eyes, but also there's other kinds of radiation, like protons that come from the sun, heavier particles that can cause damage to our cells. And we try to shield the astronauts as best we can. Because they're above the atmosphere, we're shielded here by the atmosphere quite a bit.
Right.
But above that, you don't have that natural shielding. So we have to do it with metal in the vehicle, and then some water bags around the sleep station so they can sleep surrounded by water, and that also helps absorb some of that radiation.
Okay. Now, you know, we also are kind of excited about space communications, and that's certainly another special research area. And so also with me here today is Dr. Tamitha Skov. Now, you're from the Aerospace Corporation in Los Angeles, so welcome to Central Missouri.
Thank you.
Now, you're also a space meteorologist.
Yes.
And you are also referred to as the space weather woman.
I am.
Right? So I've been intrigued by this. What exactly does a space weather woman do?
Well, most people don't realize that the sun actually has its own unique weather that comes from it. And those solar eruptions that come from the sun, they actually hit Earth and cause issues for us. So I actually do a weekly broadcast, weather predictions, just like you do, like a meteorologist, that talks about when these events hit Earth and the types of issues that they cause for things like communications, like GPS and other systems.
Okay, now we're just about 15 seconds away, actually, I believe, from totality.
Put our glasses on.
So we're going to put our glasses on. You can hear the crowd cheering in the background, and it is getting dark.
We're getting close to Bailey beads. Here we go. We're almost at totality.
And
you can see the
here we
Bailey
go.
beads. There's almost a diamond ring right there. And there we go. I think we're at totality. So now you can take your glasses off.
That is amazing.
Listen to that. You can actually see the corona a little bit even through the clouds.
That is incredible. Now, Dr. Kavande, you've been in space. You've seen numerous sunrises and sunsets from the space shuttle. How does this event compare?
Oh, this is completely different than anything I've seen before. I never saw an eclipse. I've seen a partial, but nothing like this. This is really unique, and nothing like I saw in space. Space has its really cool visuals, but this is really amazing.
You know, and I'm starting to hear the crickets. They're starting to come on out. Obviously, the street lamps. This is just amazing. Now, I'm also looking up to try to find the Big Dipper and some of the other stars, some of the other planets.
Not through the clouds, likely.
Right.
And I'm really mesmerized by this. This is a spectacular event. We've had several solar storms that have been launched, and some of them have been launched from the left side of the sun. So we're actually seeing a difference from what the corona looked like in our predictions to what it looks like now. And then on top of that, we have ham radio operators all over the state right now who are making contacts that they haven't been able to make because the upper atmosphere is just all turbulent right now, and it affects the communication signals. So we've got GPS operators and ham radio operators doing a ton of science, and it's just so overwhelming.
This is amazing. Now, my team of atmospheric science researchers from the University of Missouri, they are actually sending up weather balloons here this afternoon to try to figure out, how the weather is changing at certain height levels. And actually, here's a map of the solar radiation throughout the state of Missouri, and you can kind of see how much solar radiation is hitting the surface of the Earth here in Missouri. Just interesting. This is amazing.
It is. You can tell the crowd is just mesmerized. This is so cool. And you can even see the dips in the valleys, as you can see little areas of the sun where it's shining through more.
Right, and those create the Bailey beads that we'll see as we get out of totality, which is coming up here pretty soon.
Right.
Not quite yet, though.
Yeah, I think we come out of totality at 1:15:35 local time, and so we just have a few more seconds of that. It's absolutely an amazing event, and again, we're so lucky that some of these high clouds were able to kind of fall apart a little bit, so we could experience this.
For us, yes, and I can't believe we can actually see the corona through the clouds.
Great.
Okay,
Yeah.
that's the air horn. We're coming out of totality. We're going to have to end up.
So we need to put our safety
in just
glasses back on.
There we go. Put your Bailey beads. There we go. We got to put the glasses back on. Oh my goodness.
So as you can see, we're coming out of totality here in Jefferson City, Missouri. Ladies, thank you so much for experiencing this with me.
Thank you. Quite an experience. Thank you very much.
Yes, it was. Thank you. So everyone's excited here in Jefferson City, Missouri. The sun's starting to come out a little bit. We're going to go ahead and send it back to Charleston.
We should have stayed.
Thanks, Eric. Yadi, wow.
It's an amazing, I get goosebumps every time I see this. And so I cannot imagine how it's going to be, when we actually see it here in South Carolina.
I mean, so Alex, I'm speechless, man. I mean, as a scientist, you gotta love this stuff, right?
Oh my God, and it's so great to hear them. I mean, I love hearing an experienced astronaut talk about how overwhelming it is given the amazing things that she has seen, but also to hear my colleague Tamitha Skov, who is also a heliophysicist and a space weather expert. I can hear the excitement in her voice. I mean, it's palpable. It's just great.
Okay, so check this out, guys. I mean, I think things are going so smooth. We're going to go to another image right now from Hopkinsville. Brian Massey, out there from Marshall Space Flight Center. What's going on? You got some action there. Hopkinsville. There it is.
That's beautiful. They're getting close.
Now, it's yellow. Is that, we had purple, does that mean something there?
Well, the previous one we saw that was purple was calcium K. It was a blue kind of light. This is actually more of a white light, continuous. Yeah. But the thing to remember is sometimes the different filters you use will change the color just a little bit. But what we're seeing here is really more visible, broader spectrum white light.
Okay. White light.
Let me, John, you gotta have some cool stuff on social media.
This is a good question, guys. Mark from Facebook's asking, and this is what really applies right now. When observing the moon at night, I see it proceed from eastern to western horizon, much like the sun does. How come the solar eclipse is traveling from west to east across the U.S.?
Well, again, that's because when we're looking at the moonrise, that's actually because of our location on the Earth and the fact that the Earth is rotating from west to east, the same reason that the sun rises in the east and sets in the west. But the moon itself is moving in the same direction the Earth is rotating, and it's casting that shadow down on the Earth, and that is moving in the direction that both the moon is orbiting and the Earth is rotating. So from west to east.
Okay, so the total eclipse has now passed over half the country. It's currently over Illinois, and I think we're going to have some views coming up shortly. But what I really want to do here, guys, is this has been really incredible. I want to give a shout out to the College of Charleston. Make some noise. Oh, we're loving it here. So now we've got live video coming to us from Hopkinsville, Kentucky. It's a small town that's known for southern hospitality, like Charleston, and it's also a prime spot for viewing this total solar eclipse. Hopkinsville is the city with the longest duration of the total solar eclipse, for a total of 2 minutes and 40 seconds of totality. NASA's Marshall Space Flight Center. Brian Massey, I'm so excited. What you got, man?
Dwayne, we're just as excited as you are. We are here in Eclipseville. Say hello, everybody. Oh, we're having a great time. I'm surrounded by 1,000 of my best friends. We're getting ready. It's starting to get a little darker already. We're also joined here by NASA Marshall planetary scientist Renee Weber. Renee, thanks for joining us.
Thanks. It's really great to be here. I just want to say thank you to the city of Hopkinsville for having us out on this beautiful farm in Kentucky, and we're just all really excited.
Yeah, definitely. It's a lot of fun. There's light starting to fade, and the excitement's getting bigger. We are at the point of greatest eclipse here at Hopkinsville. Renee, tell us a little bit, what's the significance of that?
Well, the point of greatest eclipse is actually a point in time when the axis of the moon's shadow is pointed most directly towards the center of the Earth. Great. So we are at the point on the surface of the Earth where that time occurs.
Exactly. The shadow will actually be more circular here than anywhere else in the country, correct?
That's right. And it's getting really dim, and we are just so close. It's incredible.
Yeah, this is amazing. We can't wait to break out in the darkness. We've got our glasses out. We've been looking up at it. You can see now on the screen our live telescope view, and this is just amazing. Everybody is really enjoying it. We've got people from all over Kentucky, people from all over the world have joined us here, as this is Eclipseville, USA, and we are just a few minutes away from totality. But before we get to that point, Renee, tell us, you're a planetary scientist and you specialize in the moon, a lunar scientist. How does the eclipse really speak to what you do?
Well, it is pretty cool to look up there, and when you're seeing that sun get dimmer and dimmer, it's because the moon is up there.
Right.
And I like to tell everyone that you're really looking at the moon when you're watching a solar eclipse, and it's just getting dim, and it's starting to get a lot cooler too.
Yeah,
it's incredible.
Crazy. This is my first solar eclipse. Renee, have you ever experienced one?
This is my first total eclipse too. I've seen partial eclipses, but I've never had a chance to see totality before, and I'm just so excited.
It's amazing. The light is starting to fade as the moon steps in front of the sun here, and it's already just a really eerie feeling here, getting dark in the middle of the day. But we're really excited about it, and we're just a few seconds away. I've lost my counter, but I'm going to look back at the sun while I still have the opportunity. Wow, that is absolutely amazing. We're down to just a thin sliver of the sun. Renee, what do you think about this?
I can't believe it. It's just, it looks incredible, and it really is starting to get dim, and nobody even needs their sunglasses, just your eclipse glasses, and you can see that beautiful crescent sun.
Wow, this is absolutely amazing.
We're just really looking forward to that for a chance. We got no clouds here in the sky, and you can see some airplanes up there, but that sun is just getting smaller and smaller.
Yeah, it's definitely a Hopkinsville, Kentucky Chamber of Commerce sponsored day here in Eclipseville. There's not a cloud in the sky, and it's amazing how it's gotten so much cooler here since the sun started covering up started being covered.
Yeah, it's nice to have a break from that hot southern sun.
Yeah, definitely. We've been sweating it out a couple days here in Hopkinsville getting ready for this.
We're getting really close now.
So what exactly are we looking at here, Renee?
Well, we're just about close to 100%. It's just getting smaller and smaller, and it's getting dimmer and dimmer, and hopefully soon we'll have a chance to see those Bailey's beads and that diamond ring.
Right.
That's when you can actually see the light shining through the moon's valleys. The moon's not a perfectly smooth sphere. It's got that rugged surface, and you can see those sun rays shining through those mountains and valleys and craters.
Wow.
It's looking like we're about 1 minute out now, and it's just getting smaller and smaller.
Wow, this is amazing.
The crowd's getting really excited too.
Hey guys, who back there is excited for the solar eclipse? Wow, it's getting closer.
Wow. It's just getting really close to nighttime. It's incredible. It's like very dim.
Definitely it feels like dawn or dusk here in Hopkinsville right now as it's getting closer.
Come on. And you can see on our feed, there's that tiny, tiny little sliver left to go. And it's really starting to get dark now. Wow. It's like
Goodness
dusk.
gracious.
And you can see the pink color around the horizon. Oh, it's like a sunset. It's beautiful. It's going. It's going.
Wow.
Just that tiny, tiny last sliver. Oh my goodness.
And we are in total solar eclipse, and this is absolutely breathtaking.
Yeah, you can see the corona, that beautiful white wispy crown coming out from the sun in all directions. And we can see airplanes, and I think I see Jupiter in the sky over there. I think I can see Jupiter.
Wow.
And I see other planets too, and stars.
I can only imagine in ancient times what this must have been like.
I know.
Out of nowhere. I am covered in head to toe in goosebumps. A complete chill.
I know, I am too. I just can't believe we finally got a chance to see it. I mean, it's one thing to read about it, but it's another thing when you get to see it yourself with your own eyes.
Guys, we're going to take a break here just a second. We're going to step back and fully enjoy this and hope you enjoy our feed on the telescope. Eclipseville. It has definitely lived up to
And
its
now we're getting
name.
that diamond
Here we
ring
go.
on the
We've
way
got it
out.
coming back. The moon is stepping aside
And
from the
now,
sun. It is getting
totality's over.
brighter. Totality has finished here at Hopkinsville. Wow, that was absolutely amazing, Renee. Can you even try to put it in words?
I can. I mean, I just have goosebumps all over my body.
Wow, this is amazing. We can see the birds flying around in the
we can
distance.
see the sun starting to come out and it's getting bright again.
This is amazing.
It's really a once-in-a-lifetime opportunity.
Yeah,
Until the next
definitely.
eclipse
Yeah,
that we'll
exactly.
have only 6 years away. We get to see it again.
Wow, we'll be there.
Yeah.
We will be making
Without
our
a
way.
doubt. I think I'm hooked. I'm an addict.
We have sat in meetings preparing for this for the last 2 or 3 months, and now that it's actually here, it's completely 100% lived up to its billing, and I can't imagine, I can't believe what just happened.
It was just amazing. We were so worried about the weather and the
yeah.
broadcast and making sure our telescope was set up and everything went smooth, and we just had a blast.
Wow, this has been absolutely amazing. Folks, we have really enjoyed it. It's been a great time here at Hopkinsville, here at Eclipseville, USA. Now time for us to send it back to Clarksville, Tennessee, where our good friend Chris Blair is standing by for their reaction to the eclipse. Chris?
But I think he meant Charleston, not Clarksville. So let's bring it back here at Eclipse Central. There's only one Eclipse Central, and it's here in Charleston. Yeah, okay, so the hits just keep on coming through the eyes of NASA. Now, let's continue. Now, these are going to be pre-recorded views from the high-altitude WP-57 aircraft. They soar high above the clouds that could potentially block the views of today's eclipse. And they're chasing the total solar eclipse. They're mid-wing, long-range aircraft used to conduct high-altitude research. So, let's go to these pre-recorded views.
Yeah. Yeah.
Okay. Yeah. What are we seeing here, Alex?
So right now we're looking at these specially fitted cameras. They're on the nose cone of the WB-57, and these are designed to look at the corona, and they're also designed to look at Mercury. They're taking thousands of images every minute and processing this data to give us an extended view, because up there at 50,000 feet, it's 20 to 30 times darker than it is here on the Earth. Because there's a lot less scattered light. So this is a really unique opportunity. As those two planes fly in tandem, they give us about 8 or more minutes of a view of the corona. Now, the other thing they're actually looking at is, because they're so high up, it's very cold, and that allows them to take infrared observations. And in this case, Mercury is very close to the sun, and they can take infrared observations of Mercury to see the temperature change as Mercury is rotating.
That's amazing. So we're going to come back with that, but let's go, now let's go to Clarksville and see what's going on there.
All right, thanks and welcome back. We're excited to highlight some of the student science and the STEM aspect of this solar eclipse. We have several students joining us right now. Would you please tell our audience your name and what school you go to?
My name's Eliza Dellert. I'm from the University of Alabama, Huntsville.
And what club or group are you with?
I'm actually with the Space Hardware Club.
All right, and you guys have been launching balloons all day today. Tell us about the scientific payloads and the instrumentation.
Well, on our first balloon, we had a Geiger counter counting alpha, beta, gamma particles. We also had a pointing payload to get stabilized camera footage along the way. We had some hops from one of our local breweries. And then we, on our second balloon, we had a live streaming payload. So that was cool. That was probably our biggest project, thanks to Alabama Space Grant and National Space Grant. And so we were really excited with all of our experiments. They went really well.
Excellent. Well, we're glad you came here to do this. We appreciate it.
I appreciate it.
Thank you. And so that's University of Alabama in Huntsville. And so we also have another student joining us from the Space Camp, U.S. Space and Rocket Center in Huntsville, Alabama. Tell our audience, please, your name. And I just said who you're with. So tell us your name, please.
I'm Stephanie Bonifield. I'm from Pittsburgh, Pennsylvania.
And you're with the Space Camp all weekend long to get
Eclipse stuff was what the Eclipse will experience, and a lot of everybody like burning their retinas. And what experiments we'll be doing. We set up the shadow band box here that are out of the shot, but we recorded, hopefully, some interesting data about what was happening during totality. So that's pretty cool.
So you guys will go back and go over that data a little bit. Tell us about the students. Where are they from? It's not just students from Alabama.
No, yeah, we have students from all over the country and even all over the world. We have students just in my team who are from like Spain. We've got someone from Norway, all over the world. It's crazy. There's a girl in another group who's from Mexico and a boy from Mexico, and they were like talking to each other in in Spanish the other day, and that was really neat, just meeting other people from other cultures. So you really get a neat experience at camp.
Absolutely. Education is global. And so lastly with you, give us your first reaction to viewing the solar eclipse.
It's just really crazy. It is daylight here, and it was daylight before, and then the eclipse kind of comes in slow, and it's just like a glowing ring in the sky. It's incredible. It's so hard to explain. And then the lighting, it's not like dark like at night. It's like this kind of almost eerie sort of ambient lighting, and there's a sunset everywhere. And then after totality, like right after, it was like somebody turned daylight back on. The moon just moves away and it's light again. It's really awesome.
No, absolutely. It's exactly what happened. So thanks. We appreciate your time. Yeah. Thanks a lot. So we got one more student joining us. It's from the Inspire Project. Please tell us your name and what school you attend.
I am Robert Allsbrooks, and I attend Chesapeake Math and IT Academy in Maryland.
And tell us a little bit about the science experiments and research you were working on while you were here.
I was working with the balloons, and I was also working with the shadow bands and the ham radio.
All right, and how about your first reaction to the solar eclipse?
It was just amazing. When I saw the sun go away, and it almost went pitch black, and I just looked up, and it was just a ring around the sun, and it was amazing. That's all I have to say.
I appreciate it. Thanks a lot.
Thank you.
On behalf of everyone here at Austin Peay State University and NASA's Marshall Space Flight Center, thanks for letting us be a small part of this wonderful event. Right now, let's go back live for continuing coverage of this eclipse from Charleston.
Thank you. We are having a great time here at the College of Charleston, but we've got more images coming here and the International Space Station later. Let's get some images coming in from the Great Smoky Mountains, one of the largest national parks east of Rocky Mountain. Oh, wow. Alex, what is that? Looks awesome.
We're looking at the sun that's still too bright.
It's still too bright.
But it's almost completely covered. It's getting dimmer and dimmer. And this is the unfiltered sun. So we're going to go straight from this to seeing the corona directly. This is going to be a pretty cool shot, actually.
So here's still, glasses still on.
Dimmer. Still got to have your glasses on. It's still too bright to look at directly. But it's just almost like a little tiny Christmas star or something. It's crazy. It's getting tiny and tinier.
Now, why was it in the shape of a star? That's the first one I've seen.
That's oh, there it is. I can see the corona.
Oh, okay.
That's because the camera itself didn't have a filter on it, and it was too difficult to see. But we can see the corona. There's now a little black dot, and you can see the corona around it, and that's actually the closest to what we're going to see when we look at it with our own eyes when we view it here.
John, let's go to social, man. They got to be buzzing on the conversation here.
Yeah, there's a lot of questions coming in. Of course, it's trending all over social media. Let's pull up this image right here on the sidebar, if possible. This right here is just one of our users did of the eclipse from Arlington, Texas. Pretty freaking cool, showing the showing the partial eclipse on his hand. Really interesting. And then we have the Toshiba screen in New York City, where, of course, everyone there in Times Square is able to see the partial eclipse. So it's pretty spectacular. Views coming in. And we do have a few questions. I'd like to just try to get a couple in. Is it okay to see a solar eclipse in selfie mode? I see a lot of people, there's students out here, and students like to take selfies. Is that without glasses, is that okay to do?
Actually, it is if the sun's especially behind you, because if you're looking down, the sun's behind you, and you've got it in selfie mode, that actually will protect your eyes. Again, the main thing is you do not want to have it pointed directly at the sun so that you might move away and see it with your unprotected eyes.
Yes.
So let me use this opportunity to talk about safety reminders too, about just making sure, like you just said, it's the overall view.
You know, if you're in the partial solar eclipse, make sure that you always have your glasses on to look at the sun. The only time that is safe to take off the glasses is when you're all completely, like the moon completely blocks the surface of the sun in totality. As soon as you see that diamond ring effect, that's the timing to actually put back your glasses to look back at that amazing event.
And John, let's get one more social question before we go to the next phase here. We're just having too much fun here.
Starting to get cold and dark here too in Charleston. This is, I think this is pretty obvious by all of us outside right here, but is it safe to be outside during the eclipse as long as you don't look directly at the sun?
Absolutely. There's nothing different. We're just having less sunlight shining down on us, but there's no real difference, and it's absolutely safe to be outside. And we, of course, as long as you're safe, encourage that.
Yeah, go outside and watch this event.
Okay. All right, here we go. So let's talk about exoplanets. A solar eclipse is a special kind of transit or movement of astronomical body that passes in front of another. And if you've been watching along with us, you know NASA is using today's transit to further study the sun. We use similar transits to study planets outside of our solar system, or as I said, exoplanets, as they pass in front of their distant star.
While a total solar eclipse is a rare opportunity to learn more about our sun, NASA's Kepler mission has been studying distant stars for an eclipse-like event called a planetary transit. Using a space-based telescope, scientists from Ames Research Center have been measuring the changes in the brightness of stars as their planets orbit or transit in front of them. Kepler has confirmed more than 2,500 exoplanets, or planets beyond our solar system. Many of these are similar to Earth in size and distance from their sun. Studies using Kepler data have revealed a vast range of planet types and sizes, and future discoveries could help enable the search for life in the galaxy. Another major effort at NASA Ames to use eclipses to study stars in deep space is called SOFIA, or the Stratospheric Observatory for Infrared Astronomy. SOFIA is a modified Boeing 747 SP aircraft that makes celestial observations in the infrared part of the electromagnetic spectrum. Flying up to 45,000 feet, SOFIA operates above 99% of the Earth's water vapor that absorbs most of the infrared light from space. One example of SOFIA's unique qualities as an airborne observatory occurred when researchers recorded infrared imagery of Pluto as it eclipsed a distant star. What we learn from missions like Kepler and SOFIA could help us to better understand the mysteries of our sun, our galaxy, and our place within it.
All right, thank you. We're here live at the College of Charleston in Charleston, South Carolina, where it is just about time for totality. And I'm here with my colleagues, Dwayne Brown and John Yembrick, and Jari is somewhere, I believe, Carla Vega, and Alex Young. And you can see the crowd behind us. And if you look up in the sky, which I was doing just before we came back here live, we are probably at about 90% totality. And the good news from the weather standpoint is there are some clouds, but I see some breaks in them just off to the south a little bit, and fingers crossed, really tight that those breaks are going to move over as we get into totality in just a few minutes. Dwayne, what do you have to say about that?
Well, first of all, I want to thank you for, hey man, we got something. You are the man. You are the man. This is exciting. We've got our glasses. We got our scientist Johnny. Come on, get in here, and Alex here. So we're excited here at the College. Make some more noise, College of Charleston. Yeah. We are having a ball here. There's still a lot more here through the eyes of NASA. We got the International Space Station coming up. You don't want to miss it. But here we go here. Safety glasses on, guys.
Let's get in there, yeah, but we still got...
maybe a few more minutes to go till totality, but you can see. Look at that. You can see that, yeah.
Wow. Johnny, you know, even with the clouds, we can still see it. It's pretty good, right?
You guys see it?
Yeah. A little bit.
All right. I think we got some breakings in clouds. I can see.
We got a couple minutes. We still got about 3.5 minutes left.
Guys, this is amazing, right?
This is amazing.
Through the eyes of NASA.
Oh my God, it went a little bit.
Hey! Connell wants a selfie with everybody. Can we get everybody to stand up?
College of Charleston is getting a large selfie with the students and faculty and everyone here.
2.5 minutes left.
2.5 minutes.
You can't see me, but I'm here. This is so weird. This is amazing.
Dwayne, you've actually seen a total eclipse before.
I have, and it's amazing, and it's spiritual, and it really brings you in step with that. We're just a small pebble on a highway of galactic endlessness.
Does viewing this right now bring you back to that moment several years ago?
It's a little different because I'm here on American soil with you guys here, but it's still breathtaking.
Amazing. Yeah.
You know, Sean, haven't seen it in Africa and here in the U.S. Doesn't get any better than that, my friend.
No.
Here we go, almost. Here we go, it's kind of. Johnny, what is it there? Is it there yet?
No, it's hard to tell. I think that was just cloud cover.
Getting dark.
It's getting dark and it's getting cooler too, which is nice.
The temperature has dropped.
Yeah. We're still. I don't think we're quite there yet. We've got some patches of blue just a little ways away.
Weirdest thing ever happened.
still just an amazing
This,
experience.
I have goosebumps. Like, this is...
Yeah, you've done,
It is safe to remove your glasses and look at the total eclipse. You may remove your glasses.
You've got a minute and a half, right?
Yes.
Totality.
A minute and a half of totality. So we have.
Once again, it is safe to remove your glasses and look at the total eclipse.
Yeah, that's it. Wow. Put the glasses back on now.
Glasses back on. Yep. No, clouds are so thick you don't actually.
Please replace your glasses. You need to put your glasses back on to view the sun now. Please replace your glasses. You must be wearing your glasses to look at the sun.
I mean, we experienced the temperature drop.
Yeah.
And it was dark. It was dark. 2024.
Yep. Ready for the next one.
We got ISBN here, Sean.
Wow.
Okay, Sean. This is your first, right?
This is my first, but certainly not my last.
How did it feel?
Amazing. You said it yourself, Dwayne. This is amazing. That's the only word to really describe it. You know, even though we had the clouds, it was just an incredible experience. We got to experience the darkness. We got to experience the temperature drop. We got to see it in, you know, kind of moving in and out between the clouds. But most importantly, we got to experience the energy and the enthusiasm that we feel all around us here today.
Well, you know, this team in the city of Charleston, well, thank you. We had some iffy weather, but you made it happen, man.
Yeah, well, thank you. And you, you don't know the half of it. I've been also monitoring for possible thunderstorms, which we are having. We've been having just up to the north in places like North Charleston, Goose Creek. Luckily, because of a sea breeze pushing the moisture that's been bringing. Allowing these clouds to develop, moisture coming in from the Atlantic, that sea breeze has been pushing those thunderstorms inshore, inland a little bit. So even though we still have some cloud cover here, we have been very lucky not to have any rain or thunderstorms like we had yesterday at this time.
You are really a true meteorologist, my friend. Johnny! Hey, Johnny! Okay,
space weather expert extraordinaire. How was it?
It was amazing. Like Sean said, even though that we couldn't see it, couldn't see the solar corona, which is what I really, really wanted to see. We experienced, the darkness and the change in temperature, and also, the energy of the students. We even started hugging up because we were so excited. It has been an amazing experience. So the next one, 2024.
Hey, Alex. Gotta feel good, man.
This was fantastic, and it was also a big tease for the next one because, man, I want to do this again. I could feel that shadow overhead. I could see the light and the horizon all the way around, feeling the change in the temperatures, even seeing the clouds themselves moving differently as that shadow hit overhead. It was fantastic. It was palpable, man. I could just feel the energy around here, and I want more of this.
Well, let's hear what the country and all of this in Charleston. Let's go to social media. Over to you, John.
Yeah, the reactions across the entire nation have been huge. We have, actually, if you're watching at home, some of our streams actually went down only because the fact that, there was just so much traffic on it. Of course, we were broadcasting this all over the country. I want to show up on our slide, some of our graphics here, some really cool things, photos that we have here, some crescent-shaped shadows in Seattle, Washington, taken by Logan Johnson. This is a pretty interesting image, as you haven't really seen anywhere else. The next one here is a totality view from Idaho Falls. This is David Cantillo. Just some spectacular images coming in from all over. People are sending us stuff using the various hashtags out there. Eclipse 2017, which is our hashtag, Solar Eclipse 2017, which is trending on Twitter and other places. And of course, we're reading a lot of this stuff coming in too. We're seeing and reading your reactions. Some of it is just really shows the amount of how it really impacts people. And us being here in Charleston, we also saw it get really dark here, get cool breeze coming through. And even though there were some clouds, it was like nothing we've really ever experienced before. And so for those of you who are in the path of totality, I hope the views we're showing you here today have really helped you kind of get the sensation of what we're trying to show. And here's this last one here is a 99.5 near totality nerds here in Boise, Idaho, checking it out. One of our photos there. Everyone is wearing eclipse glasses, and it's we still have a partial eclipse on the East Coast. People are still seeing the sun transit, and so it's an exciting time here. I think we have another view here from Bailey Beads, seen from Oregon, from one of our photographers. This is a NASA photographer, took this shot right here. I think that's just before the diamond ring pops up, and it's pretty spectacular shot. So I think if we're ready to get going again, I think we have a quick question we'd like to take. Look at some of these here. There are a lot of these are questions coming in from eclipse viewing. Now the eclipse is officially over. I see that. What were your reactions as you were watching it? I know we were out there and stuff, but now that it's what were your reactions as you were?
We're not done yet. The solar eclipse is traveling over the Atlantic Ocean. So Alex, let me turn to you. How far is it going to go out to the ocean?
It's got another 3,700 miles roughly to travel. It's going to end just off the coast of Africa near Sierra Leone, in that area. But that's also where night begins, day ends and night begins. So we got a ways to go. There's still some more left. And maybe if you're out on a ship, you're going to get to see some more of it too.
Yeah, we have the Coast Guard 5 miles from Charleston.
Oh, well, that sounds pretty good. Well, you know what? I've been talking about this. If you just tuned in, this is NASA Television Through the Eyes of NASA. We have been bringing you unique images, reaction from all over the country. But now in 30 minutes, we'll be bringing you a view from one place no one else can go, the International Space Station. We'll check in with the astronauts aboard to see how they experience the eclipse from space. Here in Charleston, we will continue to see a partial solar eclipse for about 90 minutes or so. And remember to continue to use safe wearing, viewing, glasses, methods, and everything in between. Safety, safety, safety. Now we're going to my colleague, Karen Fox. Hey, Karen, who's out in the field getting more reaction. There she is.
We have been having a ball out here on the quad at the College of Charleston. Everybody had a great time today. We're going to ask a few questions from the people who were here. Why don't you step over here, young man? Tell me your name.
My name is Josh Petro.
And what year are you?
I'm actually a second year here.
So did you come to Charleston College, the College of Charleston, just to see this eclipse? Like, is that why you chose to matriculate here?
Oh, absolutely. No, to be honest, I love this school, and the eclipse, I've been studying the sky since I was probably 9. Since I could read, I'd take out astronomy books. So this is just once in a lifetime, honestly. It's amazing.
So tell me about it. What did you experience when you watched the eclipse? What did it feel like for you?
It was just like, wow, this is what you read in books. This is the kind of thing that you think, wow, if that happened to me, I don't even know what I'd do. And it happened.
It's fantastic here. So I have one more question. You said you've been studying space since you were young. What are you majoring in now? Are you studying science?
Actually, the plan was to do a double major of astronomy and physics, and hopefully maybe do some of that work myself one day.
Awesome. Come work with NASA. We'll look for you. Thank you so much. Thank you very much. All right. Let's find somebody else. You want to come on up? Come on over. Sure. Tell me your name.
Oh, my name is Amanda Anium. I'm a rising junior in the Honors College at CFC. I'm sorry, no, you didn't ask that, but.
But I was going to. That was exactly what I was going to ask. You're like a mind reader. Do you know what my next question's going to be?
How was my experience? It was amazing. I felt a total unity with the world. I did.
That is fantastic. So I have a question. What are you going to do with your eclipse glasses now?
I think maybe as a souvenir for my grandchildren. I think that's what I would do with my glasses.
You're going to be like, let me tell you, kids, this is where I was on August 21st, 2017.
Yeah, exactly. Yeah, she summed it up pretty well.
Fantastic. Thank you so much. We are going to go back to Dwayne Brown, and we'll be back later with more conversations from the college.
Thanks, Karen. It's always good to see the young, and I see some inspiring scientists out there. Now, let's take a look at the highlights from today's events, and when we return, we'll learn more about how the astronauts viewed today's eclipse.
Yeah, we just captured a few reactions and want to show those to you here with some graphics. This person right here is loving NASA's game day today. He's giving some shout out to us here on the broadcast, which is really quite nice. This is another one of our Twitter users from Nashville. Just some awesome photos taken by users across the internet. If you use the trending hashtags out there, you'll see, and I've been looking in here on my computer, just some amazing photos taken from the public. Some amateur photographers, it really looks like legit stuff all over the internet. Here's another one of our users. He wrote, "This was the pic of the eclipse I took through glasses. A second one I've seen in my lifetime, awesome." Here's another one. I'd like to thank the clouds for letting me look at the eclipse. It was so cool. We are not thanking the clouds here in Charleston, South Carolina, but we did get to, it's really, you could see it with bright, the sun was bright enough, you could see the partial eclipse with glasses through the clouds. It's just totality was a little bit of an issue. Here's another one on Twitter. It's very weird to be in a darkened home with not so much daylight at 2:45 p.m., yet the sun is still shining outside. And here's another one. Wife and I are currently gazing into the bottom of a box of frosted mini wheats per AdNAS advice. It's just making me hungry. And honestly, it was better than I thought. I think a lot of people across, that's one thing we're really seeing. I mean, everybody knew this was happening. I think the emotional experience that went with the eclipse, a lot of folks we're seeing online weren't necessarily anticipating that. I think it could be really heart-wrenching and scary a little bit, but also really emotional and spectacular. And here's another one. And any other day, I'd be concerned if I saw a line of people on the roof of a parking garage. Today, not so much. It is solar eclipse day. And here's our last one I want to show you all. I'm saying y'all. Y'all, oh my God, OMG, it was the coolest 2 minutes of my life. So I think a lot of people around the country were seeing that sentiment. This is the sort of celestial event that really has a big impact. We look at the sun every day, and we see it in the sky. It's a very constant for us. And all of a sudden, for it to be obscured feels a little unnatural. And I think that's one of the things we were really seeing across the internet. So thanks everyone for submitting your questions with the hashtag and for giving us your photos. We really appreciate it, and it's been a spectacular day for all of us.
You know, that's the great thing about social media, the creativity and those things are like, it's just so awesome when they post those things.
You get honesty.
Yes, and we really appreciate your support for NASA, and keep those images coming in. Okay, so we've witnessed a total solar eclipse as it moves across the entire United States. And it's incredible to think about how NASA scientists are using advanced tools to image this eclipse. So Alex, before all of this advance and here, the cameras that people use that we have now, I think people used to draw the eclipses. Let's take a little history lesson.
Yeah, so, one of the things that's amazing, so looking at the sun and eclipses is actually the beginning of modern astronomy. And before we had cameras, people actually drew eclipses by hand. And in fact, this phenomena that Jari and I study, coronal mass ejections, were first seen in an image. So if you look at this image, I had an image up from this book. It's actually an image of a coronal mass ejection. But what you're seeing here are images from 1869 showing you the corona drawn by hand. But when we look back in the past, before we had cameras, we discovered helium on the sun. That was done during a total solar eclipse. We discovered the outer atmosphere was hot, and we even were verified general relativity in 1919.
Yes. And the image that Alex was going to show you in the book is actually like 100 years before we can actually see it with a satellite. Isn't that amazing?
Okay, you know what? I want to do something fun here. All right, we're having fun. Can we have some more fun? So, Alex, and for the young students out there and folks, the future generation scientists, as I told Alex earlier, he is one of the coolest looking scientists that I've seen. He's got the earrings, got the look, but he also has something even cooler. I got to show him the shoes, man.
All right, let's see if we can get this to work. Let's show that.
Oh, no, there you go.
There you go.
Flame shoes.
How cool is that, folks? So Alex, what got you into the heliophysics and the sun? A little background.
Well, I've been interested in astronomy all my life, seeing things like Star Trek and Carl Sagan. but when I was studying astrophysics in graduate school, my professor said, you know, you ought to look at the sun. The sun is really close, and it's something we can study in incredible detail, and you can use this as a tool to study the rest of the universe. So that was when I realized that we can learn so much about our universe, why we're here, just by looking at our closest star, the sun, and all the incredible detail that we have. And this is the reason why scientists are so excited about total solar eclipses, because we can see a region of the sun in visible light with our own eyes that we cannot even see from space.
Fantastic. So, Alex, I'm going to come back to you because I understand you're a cat lover. And Jody, I know you have a fantastic story to tell. But we're going to go back out to Karen, who has another special guest. Karen, you're just having a good time out there.
I am having fun. The College of Charleston students have been fantastic supporting us today. And we have some more students here. Can you tell me your name?
I'm Nicole.
And tell me what year you are and what you're majoring in. I want to learn a little about you.
So I'm a senior at the College of Charleston. I'm studying biology. I want to do conservation work with like endangered species and fragile habitats.
Fantastic. So was this your very first total solar eclipse?
Yes.
And what did you think?
It was really awesome. I was glad I got to see it.
Tell me a little bit about what you felt when it got dark and got cold. What did you think was happening?
It was kind of just surreal. I didn't really know what was going on. I didn't expect all the lights to come on and stuff, so it was really cool.
How about the rest of you? How was your experience today on the total solar eclipse?
Unreal.
Yeah.
I'll never see it again.
You're going to see it in 2024.
Oh, really? And where? Where at?
We have another total solar eclipse across the United States from Texas to Maine, 2024. Okay. And of course, you could start traveling for them. Do you think you'll start traveling for them?
Probably not. Honestly, it was cool, but I don't know. It's kind of a once-in-a-lifetime type of thing. Yeah.
All right, I'm going to ask you my favorite question I've been asking students this week. What is the music you associate with the sun and space and the eclipse? Give me something.
Here comes the
Dark Side of the Moon.
Sing it for me.
Nah.
Come on. Okay. Here comes
the sun.
Clap for it.
Here comes the sun.
Thank you very, very much. We are doing well here at the College of Charleston, having a great time. People are beginning to leave the quad now and moving on and going on to start school tomorrow, right? So is this like the best start of school ever?
Yeah, definitely. I couldn't have started like a different way. It would been awesome.
Fantastic. We've got one more person here. Do you want to come over? Come on. Tell me a little bit about what you experienced. Was it like what you expected? What did you expect?
I expected it to get dark, but I didn't expect that temperature to change and get so cold.
I felt the same way. I was really surprised. I kept thinking it was going to rain or something, and it never did. It was fantastic. All right. What are you going to do with your eclipse glasses now?
Just keep them as a souvenir. I might put them in a scrapbook.
Oh, I like that. Don't use them if you ever get them scratched, okay? Okay. If you keep them pristine, you can use them again, but not if they get scratched, okay? You're going to be real careful with these, right? All right, fantastic. Anybody here a science major? Any one of you guys? You are? Come on up. Oh, look at your shirt. Look at your fantastic shirt. Wow, tell me about your shirt.
I don't remember where I got this, but it's obviously constellations, and it seemed appropriate since it was astronomical.
I agree. And what kind of a science major are you?
Geology and biology, probably.
And do you say that this inspired you a little bit more and be excited about science?
Yes. Really amazing.
Thank you very much. I'm so glad you all were here today, and we are going to hand it back to Dwayne Brown. Thank you so much.
Thanks, Karen. You know, and they are special guests because, you know, the kids and our future scientists are really, really important and special. And Jody, I know the audience wants to hear your story. I mean, it's amazing. I mean, we're sharing here. Tell us your story.
Well, I mean, I started interested in science since I was a little kid. I was very curious, but it was when I remember I traveled to Florida. I have family in Florida. I was 6 years old, and I went to the Kennedy Space Center, and I saw the amazing scenes that NASA had there. I put in my mind, I want to work for NASA one day. And coming from a little island, you know, Puerto Rico, hola Puerto Rico, I mean, I have to work really hard, but it's, you know, here I am. I work really hard, and it has been an amazing experience, and look where it got me.
Oh, my goodness. Well, I'm glad to be here. It's been a great day. So, ladies and gentlemen, we've been talking about this. Now it's time to go back to the Johnson Space Center to Rob Navius and the International Space Station coming up. Rob. So, okay, not yet. So, what we're gonna do, we're gonna come back here. I just love live television because you turn. But, so, now we can talk about cats.
Cat
man.
man. I'm a cat man.
Let's go.
I'm a cat lover. Yeah, so, you know, I love cats. I've always had cats. My wife has cats. And the great thing about it is they're such great companions, and I do a lot of traveling for NASA. And it actually is very convenient to have a cat because they let you go away, come back. They're still glad to see you, but they don't need quite as much care as a dog does. So actually, for all the work I've done and all the time I've spent out studying the sun from other countries, cats have always been there for me. So
2 quick questions, and then we are going to go down to
Okay.
Houston. Advice for becoming a scientist, real quick.
Well, study. It sounds simple, but just keep going to school, but try as many different things as you can, experience in different opportunities, internships, things like that, because it gives you a chance to really see the breadth of science and technology out there.
Jody.
Keep motivated. You know, like Alex said, do the internships, try different things, because you never know exactly what you really like, and to be really happy on your job, you really have to find that calling, what you really, really love.
Yeah, and for the folks and the kids and the students watching, and a lot of you out there, I mean, look, Alex and Jody, I mean, they're amazing. They're amazing. And we'll hear more about them. Now, within the past hour, as Eclipse swept across the continent, U.S. 6 crew members aboard the International Space Station had a chance to view this phenomenon from a unique vantage point. Let's go to the ISS Flight Control Room at the Johnson Space Center in Houston. Rob Navius, back to you with more. Rob.
Thanks, Dwayne. Millions of people have been witness to this amazing event across the United States throughout the day today. But up on the International Space Station, members of the Expedition 52 crew have had a unique celestial front row seat to history. About an hour ago, the International Space Station flew 252 statute miles above the Earth over southern Canada as it made its way south of Hudson Bay with a tremendous view of the moon's shadow against the Earth. The moon covering about 44% of the sun during the second of 3 passes. You can see it in this animation right here. The crew were glued to the windows of the International Space Station with an HD video camera, with an armada of digital still cameras to capture every moment of those precious seconds. With us at this hour aboard the International Space Station in the Destiny Laboratory of the complex are 4 of the members of the Expedition 52 crew, NASA flight engineers Peggy Whitson, Jack Fisher, and Randy Bresnik, and flight engineer Paolo Nespoli of the European Space Agency. Thank you all so much for joining us today on this historic day.
Yeah, it's been an exciting day for us to have the opportunity to see the eclipse from here.
Peggy, let's start with you. You were in the cupola with an HD video camera looking out at the limb of the Earth where the shadow appeared, capturing some spectacular video that we're going to replay here in a second. What were your thoughts and impressions as the station flew over the shadow of the Earth?
Well, I'd seen pictures from previous eclipse, and so I think I had underestimated what this would look like. This was much darker than I gave it credit for being. Unfortunately, it was kind of near the limb, near the edge of the Earth from our view, so several 100 miles away. But it still was impressive to be able to see that dark spot as we passed by.
For Randy Bresnik, Randy, you've been looking forward to this event for some time now. Your thoughts and impressions of the eclipse. You also shot digital still imagery of it as well. And what does a solar eclipse do to a human being? What does it do to a human being in terms of understanding our place in the universe?
That's certainly a big question. You look down at the size of the shadow, and we've gotten used to the scope and scale of what the Earth looks like from here, and just understanding how many people will be affected by that. And a friend of mine the other day, mentioned that, and it kind of really came to me, we were actually looking at it, was that just a few hundred years ago, human beings wouldn't have even known that the eclipse was coming. And so here you are looking up, and all of a sudden the sun is disappearing. And, you know, what are the thoughts for all of, you know, human existence where everybody's looking up going, the gods must be angry at us, you know, and now we have the ability not only to know it's coming, people are excited about it. We know people that travel to go be under the umbra, you know, and making an event, you know, a celestial event. And for us, being able to witness it from above was just really special because it represents how far we've come with the technology we have. I mean, look, we're on the International Space Station where we're doing, you know, more than 250 different experiments and working with an international team. Look at where we're at. And so I look forward to the next time we have a full eclipse. Maybe we'll be taking pictures from a lot farther away.
For Jack Fisher, Jack, it's good to see you this afternoon. You sent a picture very early this morning of this raft of cameras that were laid out in the Destiny Lab, ready to rock and roll to capture every second of this unique event. Was it awesome sauce ×2 for you?
Yes, it was awesome sauce ×2. And Rob, you know, this has been a huge coordination effort. Comrade Randy has been in charge of planning where all of us would be and a little orchestra of which window, which camera. So he did a great job with that. I was actually supposed to be taking off a window pane or a scratch pane right now, but due to the lighting and how we're going about it, we don't really need to. So I got lucky and got to join all these folks for the BAO event. It was, you know, Peggy said she underestimated it. I definitely did. Just judging from the pictures, that spot was, you know, a lot darker and a lot larger than I thought it would be. And, you know, I kind of was sitting in the Russian segment at the window thinking, you remember snipe hunts? I was like, man, this is kind of like a snipe hunt. I think somebody's pulling a joke on me. And then all of a sudden, this huge black shadow was going across the earth. So it was amazing, and it was cool to see from this vantage point. So absolutely awesome sauce ×3, Rob. 3 chocolate awesome sauce with a side of sun awesome sauce. I don't know. It was awesome, Rob.
For Paulo, we do remember 6 years ago, May of 2011, when you departed the International Space Station on a Soyuz vehicle to come home from your last flight. You took that signature picture of the shuttle Endeavour docked to the station with all of the other international partner components and vehicles linked up. How did today's experience compare with that moment 6 years ago?
Well, 6 years ago, I was kind of alone there on the Soyuz capsule taking pictures. So through the rest of the team, Dmitry Kondratiev was flying the Soyuz, and Katie Coleman was actually taking timing and telling me. But it was me with one camera and a video camera and taking picture. Here today we had, as you saw from the photo that Two-Fish Jack sent this morning, we had an armada of equipment. We had multiple places. We were flying back and forth from the station to the cupola Russian segment, up and down, and it was a completely different orchestrated system. I was impressed too by the shadow passing by. I've seen some pictures, but and I always, as a kid, I always thought the umbra would be kind of a square, defined square, but it was not. It's kind of a smudge, and this is interesting to actually see this from with your own eyes.
Randy, let me go back to you for 1 second to follow up on what Paulo just touched upon. It must have been a photo feeding frenzy on board during those first 2 passes. You all have one more pass to go coming up shortly. Give us a sense of that choreography that your crewmates have explained on board. And was it everybody elbowing each other away from the windows, or how did it all work?
No, certainly everyone has their favorite things that they wanted to do, but we had to divide up the tasks because we couldn't have everybody doing the same thing. And so we even, you know, took the still shots and said, okay, we're going to shoot this particular type and this particular speed from, you know, this particular person, so we're going to vary it from over here to ensure that we were able to capture the images as best we could to share it with you all. Cupola was a little crowded because we had a bunch of cameras, a bunch of people, and the big thing was to try and not bump the video cameras. Sorry for the one you saw. But when you see all the video and the pictures, it's not any one person that took them. It's the Expedition 52 crew, to include our Russian crewmates. And so that's where the credit goes, because everybody did their part, not doing what they wanted to do, which is a definition of teamwork, and that's why we're here.
And Peggy, finally for you, you're less than 2 weeks away from returning to Earth after almost 10 months on the station, having logged more days in space than any American astronaut in history. How did this show today compare with some of the other major milestones you've witnessed and experienced during your 3 long-duration missions?
Well, I think having the privilege of being on 3 different long-duration missions has given me a lot of interesting experiences, and this is just another one to put in the history books for my memory. I really enjoyed seeing this, and I think maybe a little more than I expected to. And so it's just another little piece, another memory, another very special event, another very special day of this fantastic experience of being in space.
And down at Charleston, South Carolina, an old friend and colleague of yours, Mike Massimino, is standing by. He's got a question for you.
Hey, Peggy, comrade, Two Fish, Paulo, it's Mass down here in Charleston. I got to be in the path of totality below all of you today, and it was pretty awesome here, and it made me think of some of the really cool things we see of this, the timing, the cosmic dance of the universe that we see. And for each of you, could you describe something that you've seen? Peggy, you've been up there more than anyone, any other American, and all of you. Something that you've seen that has been up there more than any compares to this, that you only see from space that we can't see on the ground.
Well, I mean, I just feel like the whole experience of being here, of living here, is on a daily basis very special. There's just very special parts of each and every day. I do think this one is very nice. We've seen some incredible auroras lately. I've really enjoyed seeing scientific research getting completed, some really cool research getting completed. And of course, you can't beat the view during a spacewalk, but it's just a piece of this huge puzzle of why being in space is so beautiful.
Another one?
Back here in Mission Control, for all of you, an amazing day and an amazing opportunity to share a few minutes with the Expedition 52 crew. I'd like to thank Peggy Whitson, Randy Bresnik, Jack Fisher, and Paulo Nespoli for their time today. And for you, Peggy and Jack, and your crewmate Fyodor Yurchikin, soft landing in your Soyuz on September 3rd. You all be well and fly safe. And with that, Dwayne, we'll toss it back to you at Eclipse Central in Charleston, South Carolina.
Thanks, Rob. Mike, thank you. It's always good to see you.
Thanks for letting me. It's
so
good to be a
much.
part of the NASA team still.
Thank you so much for
thanks for having me.
Thanks a lot.
So Mike, we got you here, man. So, you were here. This isn't your first eclipse here.
My first one, yeah. I never saw one in space, and never saw one on the ground. So this is my first one in space or on the ground. Was today.
Okay, I know you've been asked the same question, but just how did you feel? I mean, you told that it's amazing.
It was a really cool. It got a lot of people excited. This is one of the bigger events, maybe the biggest event we've had for a while anyway, and something that everyone can get excited about. Lots of people flocked to the path of totality, and as close as they could get, and I just felt there was a lot of excitement about it, which was great. I wish the weather was a little bit better here, though.
Yeah.
We had some clouds in the way, but even with that, it got dark, it got cool. When you see things in space, you don't hear anything, and you're in either your spacesuit, you can feel the warmth of the sun coming or the cool of the darkness as you're going around the planet, and you can see the Terminator between night and day and so on. These reminders of what we're about, what our planet is about, and we're all space voyagers. Here I was able to feel the coolness, right? And it got really dark. But it was a lot of added sound from all the cheers of the students here at the College of Charleston, so that was kind of fun too. So it was nice to be able to, it was good to be able to share with all these. I guess the semester hasn't started here yet.
Joe Seals back here at the RSBN studio in Auburn. We're going to conclude our coverage right now as the eclipse has already passed through the East Coast and moved its way out to the Atlantic. So we are done with our coverage here. We want to thank everybody for tuning in and watching with RSBN today, and also remind you that we will have live coverage of President Trump's address to the nation tonight at 9 o'clock p.m. Eastern Time. You can watch it right here on RSBN or on our website at rsbn.tv. We also have our crew arriving in Phoenix, Arizona tonight ahead of tomorrow's rally by President Trump. You can watch a live stream tonight of all of them. There will be 4 of them live from Phoenix tonight as our little pre-rally stream that we will have. And then tomorrow, all-day coverage of the rally from Phoenix, interviewing people and protesters outside, and also the rally inside, and a special post-game show tomorrow night as well. Please help us stay on the air. Right Side Broadcasting is viewer-supported, and we can only bring you these events with your support. We're on a very limited budget here, and traveling across the country gets expensive. So if you can help us, please go to rsbn.tv/donate, or you can click on the $sign underneath the chat box to the right of the screen. And we certainly appreciate and thank everyone for watching our coverage of the total solar eclipse of 2017. Have a great day.